Good morning, distinguished guests and scientists. Ladies and gentlemen, we believe that it's crucial for the local scientific community to share and exchange new ideas and research work with those from abroad will significantly help Vietnam accelerate international integration. The 10th International Conference on ContextAware Systems and Applications, Eai Iccasa 2021, take place in cyberspace due to the travel restriction caused by the worldwide COVID-19 pandemic. It's co-organized by the European Alliance for Innovation, Ho Chi Minh City Open University, and Western University. In organizing the conference, we are also honored to have been well guided and supported by the three co-organizers. We are happy to see the conference has attracted various prominent scientists from over 8 countries worldwide and welcome your innovative idea and research work on ContextAware System and application in an attempt to formalize the new computing system in the future. On the behalf of the organizer, we would like to take the opportunity to express our sincere appreciation to all the participants and the co-organizer for their valuable and continued guidance, support, and cooperation, which are indispensable for the success of this event. We wish you have good health, happiness, and every success in your career and development, especially in further research in the fields to further accelerate the development of computer science. Thank you for your attendance.
Dear ladies and gentlemen, let me welcome you to the Eai Iccasa 2021, the 10th EAI International Conference on ContextAware Systems and Applications. I am Aleksandra Sadziejowska, the EAI Conference Manager of Iccasa 2021. Unfortunately, due to the COVID-19 pandemic, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of the European Alliance for Innovation. First of all, I would like to thank all of you for being a part of this conference and for your involvement with EAI. Above all, I would like to express my gratitude to the General Chair, Phan Cong Vinh, for his hard and excellent work throughout the whole process of the conference preparation. During today's event, you can actively participate in two ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing the Eai Iccasa 2021 Slack workspace, you can enter the channel called Discussion. Secondly, you can vote on individual presentations and leave your fellow researchers feedback on their work through EAI Compass. I would also like to use this message to invite you to join us again soon. I am glad to announce that the next edition of the conference will take place in October 2022 at Mekong University in Vietnam. I invite all of you to participate in Iccasa 2022. Should you be interested in being a part of the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, organizing a conference or a workshop, please contact me at my email address as well. To sum up, it is our honor to organize this year's edition of Iccasa Conference. I hope you will have a wonderful time during this event and that you will follow the next edition in 2022. We will keep you posted and the news about this event will be available on the conference website. Now, our community manager Michal will talk more about what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy Eai Iccasa 2021. I hope to welcome you again next year in Vietnam.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier, and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello everyone, My name is Francois Siwe. I am a reader in computer science at the Montfort University, Leicester, in the United Kingdom. I'm very pleased to be invited to give a keynote speech at the ICCA SA 2021 conference. In this keynote, I will introduce you to the calculus of context-aware ambient that has been developed as a formal notation to specify and reason about the behavior of context-aware systems. The outline of the presentation is as follows. I will start with a motivation, then I will talk about the main features of CCA. Then I will introduce the notion of ambient. That is the main concept in the calculus. And then I will show you how to model using ambient. Then we will go deeper in the syntax and semantics of CCA. Then I will introduce the tool support for CCA. And then finish by an application of CCA to the Internet of Things. Mark was the founder of Pervasive Computing System in 1991, also known as Ubiquitous Computing System, justified the vision of that new paradigm with the following quote. The most profound technology are those that disappeared. They weave themselves into the fabric of everyday life until they are indistinguishable from it. So this means that a ubiquitous computing system or pervasive systems are systems that are aware of the environment or the context of use and adapt their behavior if the environment changes. So context awareness is a very important property for pervasive on a ubiquitous computing system. Context awareness on mobility are known as enabling mechanism for the design of pervasive systems, cyber-physical system on the Internet of Things. That's why the calculus of context awareness, CCA, was designed to model and reason about the behavior of this type of system. So CCA can help to cope with the large scale on the heterogeneity and high distribution of context-aware system. How CCA can also help to control complexity using abstraction during the system design. CCA can help the formal specification using CCA help you to get a deeper understanding of the system behavior through simulation and visualization. There are tools that have been developed for that. Also, we can use CCA to analyze the correct property of safety critical component of the system. Here are a couple of examples of context-aware system that by abbreviation, we call it CAS, CS. One of them is the smart home, where appliances are interconnected in the home network. So your fridge, your home computer, the security system at home, the light, the doorbell, they are interconnected and that can extend information. So in the near future, our street will be will look like this. So we have self-driving car moving around by themselves without any driver, using their context awareness to guide themselves in the street. Then the city of future, which is also known as a smart city, is a city where the water system, the electricity, the energy grid, and the transportation system are interconnected, and that can extend information. That will ease the management of those mega smart cities using technology. So CCA will help to specify that kind of system. So here are the main features of the calculus. So the one of the feature is the concurrency, means that we can have many systems running in parallel at the same time. So it has the feature of context awareness. Processes in CCA can be aware of their context so that they can change their behavior depending on context. Mobility is also an important feature in CCA. So the concept of ambient that I'm going to introduce later is a way to represent any entity in a smart system. Then those entities can be mobile, like a car, like a user. That kind of mobility can be modern in CCA. Then here is the URL to the CCA website, if you want to have more detail on the calculus. So what is an ambient? As I said, an ambient is a conceptual representation of a thing. So any of the object that you see on this slide can be represented as an ambient. The main characteristic of the ambient in the calculus is that the ambient can have the capability to move, it can be mobile, it can have the capability to be able to sense the presence of other ambient. The ambient also can have the capability to exchange messages with other ambients. And an ambient can also contain child ambience. So a CCA process is a hierarchy of ambient. So how do you represent an ambient in the calculus? An ambient has a very simple notation. Here in the textual representation, you give it a name and then a behavior. So an ambient has a name and then it has a behavior. The name is represented here by N and the behavior is represented by the P for process. So we also have a graphical notation just to increase the legibility of CCA process specifications. So you can use graphical notation or you can use textual notation. So how do we model using ambient? So we can represent any entity in the smart environment as an ambient. So we can represent a smart device as an ambient. You just have to give it a name and then a behavior. We can represent the location of the smart device as an ambient. In this example here, you have a device here, let's say a sensor that's located in the kitchen. So the kitchen here is a location, but we can still use the concept of ambient to represent it. We can also represent the context of the user of a device. Here you have Bob and Alice in the kitchen. That's the context. Okay, so Bob's using a mobile phone and Alice is holding a tablet. We can represent it like that. So you can see here, the phone is with Bob in the kitchen while the tablet is with Alice in the kitchen. So we have a holistic approach to system design here. So we take into account not only the process or the device, also the environment in which the device is deployed. Okay, so we can consider different scenario. In this scenario, you have here the kitchen is next to the dining room, and then Bob is in the kitchen carrying a mobile device, and Alice is in the dining room using a tablet. So you can describe the environment using the concept of ambient, and then the ambient hierarchy structure. So that's how we model using ambient. The calculus also allows ambient to be mobile. This is an example here. So I have Bob in the kitchen and I have Alice in the dining room. So we will give Bob the capability to move from the kitchen to the dining room to join Alice in the dining room. So here you have the out, means that you move out of your parent. Then you have the capability in that allows you to move in another ambient. So Bob's going to move out of the kitchen, then into the corridor. Then it's going to move inside the dining room. Then it's going to move inside the dining room. So the ambient mobility is performed using the out to move out of a location and the in to move in a location. Ambient can send messages. They can send messages locally. That means inside the ambient using the send and receive capabilities. Okay, this is a semantic for that. If you have these two processes, the first process want to send a value A, and then the second process want to receive in a variable X, the reduction is going to produce a process which is the continuation of the first one, which is P here, and in parallel with the continuation of the second one. Here, this notation between curly bracket is the substitution of X to the value of A. So as any process calculus, we have a reduction semantic for CCA. These are the semantic rules that allow to do that kind of reduction. The semantic rule that allow to do that kind of reduction. Okay, so we can also have parent to child communication. A parent M here receiving a message from a child ambient N. Then the reduction is going to happen, and then the data is going to move into the parent's process. Okay, you can also have sibling to sibling communication in a similar way. So I have two ambient which are sibling, they can send messages in that way. Okay, so here's the syntax of CCA, of the CCA processes. So the behavior of ambient is described by a process. So this is the language that you use to specify the behavior of a process. The first process is the null process. It does nothing. The 0, it does nothing, and then terminate immediately. So we have here the prefix process. It performs a capability M and continue like P. We have parallel composition of two processes here. Then you have here the replication, like in the pi calculus. This is a process that creates a new copy of P every time. That can create a new copy of P anytime. So new and P here, this process here is a restriction process. So it says that the name N is local to the process P. So this is a notation for the ambient N with the behavior P here. Then you have the context guarded prefix. So this is a prefix. This is a context guarded prefix because you have a context expression here to control the execution of this process. Okay, so this process is executed only if the environment satisfies the context expression here. So let's say that a context expression is a formula over the context. It's a property used to express the property of the environment. A context guarded prefix is executed only when the environment satisfies the specified property here, the K here. The find process here is a search process. It look for value y1 to yn such that the formula, the context expression K is satisfied for those values. Then it's going to use those values in P to do some form of computation. This is a generalized if statement. It has many branches guarded by context expressions. Then you can also have a else branch for the if statement. So the let statement is used to do some form of arithmetic operations. So we are going to evaluate the arithmetic expression E1 until EL and store those values respectively in X1 till XL. And then the variable X1 to XL are used in P. Okay, so that's how we do the arithmetic expression and use the result of the evaluation of those expressions in P to do some form of computation. So the last one is a proc. The proc here introduces a process abstraction. So you define a process abstraction that has a number of parameters, and then the body of the abstraction is given by P. So process abstraction can be think of as a procedure or a function in programming languages. So I define a function that you can call at different places in your specification. So that's for the language, the grammar for processes. So now we are going to talk about capability. So the capability are the atomic action that an ambient can perform. As we just saw, we see that there are movement capability like in and out. The skip here is just it doesn't do any computation, but it takes time. It's one transition. Then you have a del. You can delete an ambient name n. Then you have the communication capability like send and receive, right? Send and receive. Alpha here represents the location. Whether it's a parent or a sibling or is done locally or a child. Okay, to represent a sibling, we use the double colon. To represent a parent, we use the at. Then to represent a child, we use the key. We use the hash key. Okay, locally we don't use any symbol. That's why we represent here by epsilon here. That means an empty string. Okay, that's for the capability. The capability are the atomic action that a process can perform. Then we're going to talk about the context expressions. The context expressions are formulas that allows a process to control, that allows the process to sense the state of the environment. Okay, so we describe the state of the environment that has to be certified for a process to be performed using context expressions. So this is the logic. It's a modal logic. The two main modalities are the next. These are spatial next modalities that allow, under the somewhere modalities that allow to look around the ambient hierarchy to see if certain property hold somewhere in the ambient hierarchy. So we have true that hold for any context. You have n equal to m. It's a name match. It holds only if the two names are exactly the same. So this here refers to the actual process. And then the not and the and and the or they use the usual. They keep the usual logical meaning here. Then you have the parallel composition here of two formula here, two context expression here. Okay, this is when the whole if the context can be split into two parallel components such that k1 hold for one and then k2 holds for the other component. Okay, so this one here, the location here, n between square brackets k represent here an ambient, the internal context of an ambient. That represents an ambient with the internal context k. So I have an ambient n whose internal context satisfies the property k. Okay, this is an example. Use that language. You can define many predicates. You can define many predicates depending on application. Here, the first one has allow ambient to check if it has a child ambient called n. At allow ambient to check if that ambient is at the location n. The with allow ambient to check if that ambient is with another ambient n. So and then the second one with two parameters allow to check if at n, m allow to check if n is located, if m is located at n, if m is located at n. The next one with n, m check if n and m are together. Okay, to have the same parents as sibling ambients. Okay, so how do we define the semantic here? I'm going to go very quickly about the semantic of context expression. Sorry. So, what is a context? We have to have a good understanding of what contexts are. Based on the definition by Day in 1993, that's widely used in the literature. A context is any information that can be used to characterize the situation of an entity. An entity is a person, place, or object that is considered relevant to the interaction between a user and an application, including the user and applications themselves. So that's a very general definition of context that that encompasses different aspects of the environment. For example, the user location, who the user is with, the nearby people and resources, the user preferences. All of these are taken into account are covered by the definition given by Day here. So we design the context expression in such a way that they are able to represent this kind of context. It's a logic that can be used to specify the user location, who the user is with. On we hereby user we understand the ambient, which relates to an ambient, where the location of the ambient, who the ambient is with, the nearby ambient resources, and then the preferences as well. Okay, so how do we represent what we understand that context expression are formula that characterizes the property of a context. So what's a context? How do we represent a context physically? So in CCA, a context is like a process with a hole in it. And then the hole is represented by this circle with a dot inside. And that represents the location of the process. That context is the context of. Okay. So this is the language to represent a context. It's like a process, but it contains a whole. So we are going to have things like a context 0 that represents a context that contains no information. The context that represents the context, the circle with a dot inside that we call whole, that represents the ambient or the process, that point on the actual process itself. It represents the process itself, the location. It's a placeholder for the process itself. The process, the process itself. And then we can have a context that has this form. It has the ambient, and then it has what is inside. It has the internal context of an ambient N. So you can have an ambient. You can have a context parameter process. Then you can have a restriction in context as well. Here, note that because of this syntax, we only allowed a maximum of one hole in a context. We cannot have more than one hole in context. Or it's a process, or it's a process in parallel with a hole, a sub context that contains a single hole. Okay, so this slide just explains what I just talked about. So now we define the semantic. Let's look at an example first. I think, I have an example first. So here I have a context here. We remember we had Bob and Alice in the kitchen. Bob having a smartphone and Alice having a tablet. So if you want to look at the context of the mobile phone, of Bob's mobile phone, we just replace the Bob mobile phone by the whole. And then that becomes the context of the mobile phone in the kitchen. So you see that the whole represents the location of the mobile phone, and then the whole all of this represent the context of the mobile phone in the kitchen. Okay, based on the ambient hierarchy. So in the context of the mobile phone, you have Bob, you have Alice, you have the tablet, then you have the kitchen organized as described by the hierarchy. Okay, so that's an example. So we use that context model to give a semantic to context expression. So now we use the satisfaction relation here to define the semantic of a context expression with respect to context. So we will say that the context expression true is is certified by any context. And then if the name, the relation name equal to the name, the identity, if the name, two names are identical, they are certified by any context. Okay, the context expression, this is only certified for the whole context. Then you can go on to define the other property, the other context expression, the semantic order context expression. For example, the not K here, if C certified the not K, C certified not K if and only if C doesn't certify K. And then C certified K1 parallel K2 if and only if C can be decomposed into two components, parallel components, C1 and C2, such that C1 satisfies K1 and C2 satisfies K2. So these are just examples of rules. I didn't want to go for the whole semantic here. So if you want to know about the whole semantic, we can visit some of our paper. I'm going to give the list of the paper at the end of the in the last slide in the references. Okay, let's talk about tool support for CCA. So as talk about the language, how we can use the language. This is the tool support. We have two tools for CCA: CCAPL and CCA Spin. So CCAPL is the interpreter for CCA. So any specification of CCA can be executed. That's very important because if you can provide a prototype of your system, you can simulate your system at the early stage of the system design. Okay, so here the CCAPL, what it does is that it receives as input your specification, CCA specification. Then it can produce different type of output. It can be the execution traces, it can be a communication graph, or it can be a behavior graph. So it can produce the output of CCA, it can be textual or graphical, just to make it easy to understand the behavior of the process being simulated. So in practice, we use CCA as a simulator. So this is the execution traces, the textual output here. So you can see all the communication or movement of the different ambient here. Okay, so when you look at the first one, it says that it's a local communication. Do I have a ambient called sensor that set the value 10 to himself. Okay, so here this is the sender, that's the receiver, and between parentheses is the message that has been sent. Okay, you can see that like that in the graphical notation. That's the communication graph. You see all the interaction that has taken place, the send and receive that's taken place in the specification, your execution. So at the top of the graph, you have the list of the ambient involved in the execution. So in this example here, you have 3 ambients: the sensor, thermostat, and then the heating. These are the 3 ambients that's being involved. Okay, you can also have a behavior graph. A behavior graph looks like a communication graph with the list of ambient at the top, but we see boxes like that. The gray boxes here show the movement of ambient. For example, the first box at the top means that Bob has moved from info station 1 from IS1 to the root ambient. So it shows the movement of ambient. Okay, movement ambient in the box. So Bob moved from IS1 to root, for example. Here it moved from root to IS2. Okay, then the horizontal arrows represent the communication, and then the label on the arrow represent the message that's been exchanged. Okay, that's for CCAPL. Another tool is a CCA Spin. So it's a verification tool. So what Spin does, so is you write your model as previously in the CCA case, but you can also provide a property, a formula, a property that you want to check. You want to check if the model certifies a certain property. The language used here for the property specification language here is LTL, linear temporal logic. So you as input you provide your CCA specification and the property you want to verify it. And then as input to CCA spin is going to generate a Promela specification. So it's going to combine the two input and produce a program in Promela. Then Promela is the programming language for spin. And then you can use a spin model checker to execute and verify the Promela model that's been produced by CCA spin. Then after spin has processed, then you can see how the verification report. Okay, produce the verification report. Spin has a very nice graphical interface that's very user-friendly, so you can play around with it as much as you want. And there are different type of, you can check for deadlock, you can check for reachability, you can check for assertions, you can check assertion violation, anything that you want. Safety property as well. Okay, so that's the idea that spin produce from CCA produce a Promela program. That Promela program can be executed by spin, and then the spin is going to do the verification and produce the output. So this is the interface for the spin model checker. Okay, let's look for an example now. I said I'm going to show you how we can use CCA to specify IoT systems. In this case, I've chosen the Cisco packet tracer that's been extended to cater for Internet of Things. So initially, the packet tracer tool was designed for network simulation developed by Cisco system, ENC, as a network simulator. Then from version 7, that's been extended to simulate also Internet of Things, to design Internet of Things. So in the Cisco packet tracer, you can design your system like that. So you have a mobile phone that's connected to a cell tower. Here, and then you can have here you have a switch, you have a router. You have different kind of modem here that you connect them together. And then here you have, for example, a smart home here with a smart lamp, a webcam, a PC, and a coffee machine that are connected together through a home gateway. Then here you have the office that contains a lamp, a office computer. And then in this network put together, you can control the lamp, the devices in your room from your office, or you can control it from using your mobile phone in the street. You are in the street, that you can turn the light on or off in your home, or you can turn the light on or off in your office. You can switch on the coffee machine before you get home. So this kind of, you can set that system in Cisco packet tracer like that, and then you can simulate it as well. Then you can play around with it. So what we're trying to do here is we're going to show you that we can translate this into a CCA program or use our verification tool for it, simulation verification tool, to analyze it. So what I'm going to show you, how you can translate each of these devices into a CCA specification in a very straightforward manner. So the different devices used in Cisco packet tracer are the network devices like router, switches, hub, Wi-Fi, access point, cell tower, and so on. Then you have the end devices like PC, laptop, tablet, smartphone, servers. Then Cisco referred to IoT devices as ROE device. ROE means Internet of Everything. Okay, so this includes home appliances, fan, door, light, other component, electronic component like boards, like macro controller unit, simple board computer, sensors, actuators. There are different type of connection. You can have any type of connection you want to use: coaxial, fiber, USB, copper, crossover. Okay, so all of these. So here we show you how you can model IoT device is actuators. This is a template for actuators. Actuator is a device whose state can be changed by the controller. So it's a electromechanical device. It has a content electromechanical device that allows to change the state, here, usually depending on the output from a controller. So we can specify it like that. So it's an ambient. You represent any actuator as an ambient that receives a signal, a command from a controller, perform the command, and terminate. Okay, perform the command. It always receive from the controller a command from the controller to turn on or to turn off. Then perform the command and wait for another command, and wait for the next command. Okay, that's how the actuator works. So this is the general structure for actuator written in CCA. So for any given actuator, you just have to change the name and change the connection and set the connection properly to the appropriate controller, and then it's ready to go. So it will work. Okay, environment variable are used to model the state of some phenomenon in the environment. It can be the temperature, it can be the light, it can be, so you have environment variable to do that. So this is how you can specify the environment variables here. So you provide some model of, so you're going to receive a number of data from the surrounding or user data to produce an outcome. User data to produce an outcome. That's going to be sent to the sensor. So this is the template for any environment variable in the system. Sensors are devices that can read the environment variable. They receive messages from the environment variable and then can send that information to the controller. So the sensor is going to connect to the environment variable and then receive the information from me and then send it to the corresponding controller the controller is connected to. So this is a template for that. So I have a sensor name. It's connected to a sense the state of a specific environment variable. Then here you receive the value from that, and then it send that value to the server. Okay, send it to the server. The server is going to refer to the sensor, so it's going to receive the value. Okay, so here we have the microcontroller. Okay, microcontroller like Arduino. Okay, this kind of board. Okay, you can program Arduino using that. You have the famous loop function here. We represent the loop function by using a process abstraction. So you have proc and then loop, and then you put all the definition here of the code that's going to be executed continuously. And then another statement that's very important when developing code for microcontroller is the delay. Okay, the time delay. Here we can use a skip to model as an abstract time unit. Okay, we use skip here as an abstract time unit. You can use skip to model time in the microcontroller here. It's abstract time because it can be 1 minute, it can be 1 second, it can be 1 day, depending on what the application is. Okay. Then you define the process, then you can call it, then you call it there. So it's going to run forever. Okay, how do you represent a wireless access point? Here, the main thing here, wireless access point can be represented as an ambient. So the range of the access point is represented by the boundary of the ambient. Okay, so any ambient that's inside any ambient or device that's inside, which is a child ambient to the wireless access point, is thought to be in the range of the access point. Okay, so that's how the access point interact with the child ambient, which is the device that's in range, that represents the device that are in range with the access point. So that's how the communication takes place. So you receive the message in terms of sender, recipient, and the message, do some computation in P, and then eventually send the output. Okay, so design pattern for user device. A user device should be able to send or receive messages. So here, very simple abstraction of user device. We don't care if it's a mobile phone, or if it's a tablet. It need to have the capability to send and to receive messages. So we can represent it like that. Then you can represent your mobile phone, your iPad, anything that any device, communication device that you have, you can represent it using this template here. Send or receive. In IoT, especially for access control here, another important identification when the RFID system is very much used. So RFID tag or card for us can be represented as an ambient. It's just an ambient that stores a number. The ambient store a number. That's what it is. Here is a number. So it's an ambient that's willing to send a number all the time. That's the number. That's inside. That's the number represented by the RFID. That's the RFID number. So you try to send it out. That's what it is represented by the ambient. That's willing to send all the time. Then you have a RFID reader here, which is ambient, which is willing to read from a RFID. So when it reads from RFID, it's going to send to a server. So the server is going to check if the number that is received is correct or not, and then reply with to change the status of the reader. So the reader is going to turn the reader is going to turn red if the number is not good. It's turn to green if the number is a good number. Okay, and then based on that information, the server can also open the door if it's used for your access control. Okay, design pattern for server. Server also a very important component when in the Internet of Things. So you have to store, you have the cloud, you have to store information on the cloud. Some of the software that are shared are stored on the cloud. So devices have to have access to the server most of the time to do certain computation. So server is important, but here in the abstraction used for server here is very simple. So a server is an ambient that receives information, as receive a request from the client, perform the request, and perform the request. Okay, that's what it is. A server receives a request from the client and process the request. That's what it does all the time. It does that all the time. That's why we have the exclamation mark here. That corresponds to the replication. It repeats itself all the time. So this ambient here, the first ambient here, this first specification here, the ambient, let's say, this send at the end and this pair of send are used for synchronization. So when they receive a request, it processes a request before it can take another request. But if you want to process many requests at the same time, you can use a second specification here. You receive a request and start processing it. During that time, you can receive another request because this exclamation mark is going to create as many copies of this process as needed. Okay, so this is a specification for route for the switches. Okay, I will explain it in the same way. So you have a template for the switches. To the switch, you can connect many devices before you connect them to a router. Okay, this is a specification for a router as well. Okay, so a little bit more elaborated, but to cope with routing tables. So I want to record a routing table. The way we do it, that we use a notion of subnet address, and then you have an ambient hierarchy of ambient to represent the root, okay, to represent the root. So in this structure here, we say that, for example, here router 2 here, to reach router 2, you have to go through router 2. Or to reach router 3, you have to go through router 2. Depend on the architecture, or the structure. So you say here, to reach the subnet address, you have to use the following hop to do that. So that kind of hierarchy to do that. Okay, so let's look at an example here, kind of application of the template I just tell you. So we have here a simple smart garage here. We want to control access to this garage using a RFID reader, a server, which is a home gateway, then a lamp. We suppose that the lamp is inside the garage here. So when the user show RFID card, if it's allowed to access the building, the door is going to open and then the light is going to turn on. Otherwise, what is going to happen? Okay, it's going to be locked out. Okay, so we can use those templates that we mentioned to represent the lamp, which is the actuator. Here we consider the lamp as an actuator. The RFID reader, use the spec, and then the home gateway is a server. Okay, and then the ambient for the garage, like that, is also an actuator that can open and close the door. That's a garage door. Can open and close the door. It's also an actuator. So you put all of them in parallel, all those components in parallel, then you get a system. Then you can run it and get a simulation of it. So here you can see all the components that are involved, all the ambient that's involved in the simulation, in the specification. And then you can see all the behavior here. This is a timeline here, the behavior here, all the information that's being exchanged. So in this case here, the RFID had a number. It set the number 102 to the RFID reader. RFID does forward the message to the home gateway. The home gateway say that is valid. Say that is valid. Because it was valid, the home gateway open the door, turn on the light or open the door. It turn on the light, it dim the light, and then open the door. Okay, and then the process continues. Okay, so that's what you can do with CCA. In this presentation, we talk about the main features of CCA, the notion of ambient that's used to represent anything in the environment, whether it's a device, whether it's a table, whether it's any object in the device. So we show you how we can use the notion of ambient to model ContextAware Systems, Internet of Things. Then we talk about the syntax and the semantic of CCA, and then also present the main tool support, CCAPL, which is a simulator, and then the model checking tool, which is CCA Spain. We also show you how we can model the Internet of Things system using CCA. We provide a number of templates, a design pattern that allows you to put together very quickly the specification of any IoT system. For further study about CCA, we have got I put here a number of references that you can use. I also mentioned at the beginning the URL to the website of CCA. Thank you very much. Thank you for your attention.
Thank you for the opportunity to present our paper titled Adapt and Flex or Die, a systems approach to an unhealthy healthcare supply chain at Eai Iccasa 2021. I am Gabrielle Pico from the University of Auckland. For this presentation, I will first introduce healthcare supply chains and their importance in the context of the global COVID pandemic. Then I will outline the design science research methodology that we used for the research. Next, I will discuss adaptive and flexible healthcare supply chains as a solution to some of the problems that we identified in the literature. Then we will take a look at the system dynamics, causal loop models of healthy and unhealthy healthcare supply chains that we developed. It was these causal loop models that informed our proposed models of adaptability and flexibility, supported by core information systems to enable transformation of a healthy healthcare supply chain. And lastly, a brief conclusion. I think we all agree that the COVID-19 pandemic has significantly disrupted the dispensing of healthcare throughout the world, and much of this disruption can be attributed to healthcare supply chains and how they function. The key supply chain elements of flexibility, adaptability, coordination, collaboration, and knowledge elements, which are common to many fully functional supply chains, are also the key differentiators between a healthy healthcare supply chain and one that is dysfunctional, which we define as an unhealthy healthcare supply chain. And it was this concept of an unhealthy healthcare supply chain that motivated this research. Also, the motivation stems from seeing key problems arise from the COVID vaccine distribution across the globe, particularly when it comes to the global supply chain networks. However, the aim of this research goes beyond just mitigating these global supply chain problems. Rather, the purpose is to promote resilient, sustainable health systems that focus on the health and well-being of people through the identification of issues within the healthcare supply chain, and ultimately provide solutions using principles of e-health, supply chain management, and information systems. Healthcare supply chains have been defined as the backbone of healthcare delivery, adding that this arises from the fact that the quality of healthcare delivery is due to the healthcare industry being dependent on the availability of medical supplies at the right time and in the right quantities to patients, lack of which may create customer dissatisfaction. Interestingly, healthcare supply chains, like most traditional supply chains, can be viewed as three delineated sections: upstream, middle, and downstream. The upstream section refers to the part within the supply chain that is used to produce the various supplies. For example, in the context of COVID, these would be vaccines, medication, masks, and equipment, while the downstream section represents the end customer, which in the case of a healthcare supply chain are the healthcare providers, again, such as hospitals, clinics, home health services, and so on. The middle section consists primarily of entities engaged in providing financial and third-party support services, entities such as banks, insurance companies, and third-party administrators. This middle section of the healthcare supply chain also deals with government regulations and compliance. Where the healthcare supply chain is different from traditional supply chains is in terms of the extent to which a partner or consumer participates, the degree of customization of the service provided, and the inherent process uncertainty. And all of these contribute to healthcare supply chains being more dynamic and complex than other supply chains. This once again leads us to the aims of this research, which is to examine problems arising from the pandemic and provide solutions using principles of e-health, supply chain, and information systems. Given the aims of the research, a design science approach was deemed to be the most appropriate. We observed supply chains during the COVID pandemic through academic as well as grey literature, with a particular focus on the key problems. Considering these observations, we then theorised both current and potential solutions to the problems that we'd identified. This theorisation included the development of high-level conceptual frameworks, as well as system dynamics causal loop models. And then, based on these frameworks and models, we've proposed a set of core systems as a foundation for a healthy healthcare supply chain. These systems are already available in the technological ecosystem and can be integrated to provide the functionality and requirements that we are proposing. As mentioned, both academic and grey literature was used to highlight the key elements of a healthy healthcare supply chain and an unhealthy healthcare supply chain. The primary supply chain elements that percolated to the top, again in the context of the COVID crisis, were adaptability and sustainability. For example, each country or state had a different response to the pandemic. In each instance, decision makers prioritised the economic, environmental, societal and cultural aspects of a country or state differently. This implies that healthcare supply chains will often be directly correlated with the country or state's approach. An example of this was New Zealand's response to the pandemic. New Zealand was able to lock down the country, and they had outstanding success in decreasing the amount of community transmission. This response allowed New Zealand's healthcare supply chains to focus on being preventative and concentrate on the vaccine distribution. Yet other places in the world don't have the luxury of New Zealand's geographical remoteness, which allowed the country's borders to be closed and effectively isolate the country from the rest of the world. Hence, a proactive, preventative healthcare supply chain approach will set the standards for its processes, ultimately affecting both patients' and employees' health. As the framework in this slide suggests, all these key elements should be aligned, corrected, optimised and monitored through a sustainable learning flow. It is suggested that system dynamic techniques are important to understanding complex systems, and there's no doubt that healthcare supply chains fall under this category of a complex system, considering its numerous elements. Modelling a healthy healthcare supply chain and an unhealthy healthcare supply chain needs to be done holistically rather than isolating each element of the system. This allows for the variables to be identified and the relationships to be highlighted. More importantly, a supply chain model can be viewed as one system with several different elements and associated variables, allowing for problems to be identified and the potential solutions revealed. The framework we presented in the previous slide conceptualized an adaptive and flexible healthcare supply chain at a high level of abstraction, while the causal loop diagrams you see illustrated in this slide depicts the variables and relationships of an unhealthy healthcare supply chain at a lower, more detailed level of abstraction. For example, the problems that arose from the COVID pandemic, including a lack of coordination, fewer suppliers available, a shortage of workers and limited capacity, which among others are key contributors to an unhealthy healthcare supply chain. Both the literature and the CLD of an unhealthy healthcare supply chain presented in the previous slide indicated the critical primary elements of a healthy healthcare supply chain are adaptability and flexibility. We argue that a healthy healthcare supply chain that can withstand the impacts of a global pandemic and respond effectively is one that is flexible and ultimately adaptive. Referring to the framework on this slide, we propose that a certain level of education and automation can be realised through achieving visibility, coordination and collaboration. Once education and automation are realised, flexibility needs to be incorporated, which finally contributes to adaptability. We suggest that once all these 7 elements are obtained, the previous unhealthy healthcare supply chain will become healthier and transformation will take place. The 7 elements of adaptability and flexibility were applied to develop a causal loop diagram of a healthy healthcare supply chain in order to obtain a systems view. The causal loop diagram, which is illustrated in this slide, highlighted potential solutions for the problems that we had identified in both the literature and the systems model of the unhealthy healthcare supply chain. The various variables of the causal loop diagram and their interconnections indicated several significant relationships. For example, an increase in automation not only increases supply chain coordination, but also increases supply chain capacity, which in turn leads to more skilled workers who experience higher levels of job enrichment that motivates them to provide higher levels of customer service. In terms of recommendation for increasing automation, healthcare supply chains should invest in robotic processing automation to achieve, among other benefits, high levels of coordination along the supply chain. What I've just described is just one of the potential solutions highlighted by the healthy healthcare supply chain systems model. Clearly there are several others, which we elaborate on in the paper. The problems identified in the literature have made it extremely hard for healthcare supply chains to function effectively during the pandemic. There is a significant amount of literature that reinforces the role of information systems to achieve adaptability and flexibility in healthcare supply chains. For instance, several authors have identified healthcare supply chain management practices, types of flows and information systems that impact healthcare performance. The adaptability and flexibility elements, which we have discussed, are illustrated in this core systems framework to optimize the current supply chain landscape through different types of IS. Incorporating these elements through the implementation of appropriate information systems can make the process of optimizing a healthcare supply chain much easier, which enables significantly higher levels of supply chain effectiveness and ultimately healthcare providers and patient satisfaction. We recommend several core information systems to achieve the transformation of a healthcare supply chain. These systems include transaction processing systems, workflow and knowledge management systems, and decision support systems, to name just a few. Again, these systems and their role in transforming healthcare supply chains is discussed in more detail in the paper. And to conclude, healthcare supply chain research has burgeoned over the years, particularly with an increased focus on technology and IS. This paper aimed to first look at the problems that arose from the COVID pandemic and provide solutions using principles of e-health supply chain and information systems. To build upon and contribute to the current research, we first looked at healthcare supply chain literature from a post-pandemic perspective. This and other literature was observed from two main views: an unhealthy healthcare supply chain view and a healthy healthcare supply chain view. Two system dynamic models were developed to showcase relationships between the different aspects and to elaborate on the views. Each of these aspects and their relative relationships were taken from the literature. 7 fundamental elements of healthcare supply chains were observed in the context of the post-pandemic world and provided the basis for the proposed fundamental elements of adaptability and flexibility framework. In addition, these elements were interwoven with 7 types of relevant information systems to create the proposed core systems of adaptability and flexibility model, which supports the transformation of an unhealthy healthcare supply chain to a healthy healthcare supply chain. This research is by no means definitive, and the solutions provided will not be applicable to every supply chain. However, the elements of adaptability and flexibility and the system dynamic views of unhealthy healthcare supply chains and healthy healthcare supply chains provide the basis for further research. Thank you for listening.
everyone, my name is Mina Ku. It is my pleasure today to present on behalf of Johnny Chen, Gabriel Pico, and David Sundaram, who are co-authors of the paper Knowledge Management Practice, Innovation, the Path to Organizational Performance. Background of the paper. In the last 20 years, interest in knowledge management practice have been establishing among organizational performance studies. Alavi and Leitner point out that knowledge management practice, which frequently depends on information technology, would lead to a robust shift in firm performance, such as improving internal communication, staff engagement, problem solving, financial performance, team performance, innovation, and business strategy. Additionally, governments around the globe have been facilitating business innovation as knowledge becomes inherently more consistent, safer, and faster in transferring. Firms invested in knowledge management systems show a remarkable transformation in internal communication and a decline in operational costs. Practical problem. Even though the implementation of knowledge management systems have been proven to be crucial for organizations, the design of knowledge management practice is generally a challenge for managers. This is due to the involvement of knowledge management practice to multiple aspects of organization. Therefore, success of such practice depends heavily on the optimal choice for other organizational factors as a whole. Research problem. In addition to several symbolic qualitative research that lays a crucial conceptual framework and theoretical foundation for knowledge management discipline, there is a growing number of quantitative studies using precise modeling methods to measure the impact of knowledge management practice on organizational performance. These works have been carried on large-scale datasets to efficiently deliver reliable empirical evidence that shows the significant effects of knowledge management practice on organizational performance. Although there is a number of quantitative studies on knowledge management practice and organizational performance have been carried on, the descriptive analysis might not efficiently cover all the aspects. These studies generally focus on knowledge processes and practices on the financial performance of the firms, and studies on knowledge management practice paths of influence to organizational performance has not received sufficient attention. Existing studies mainly focus on using data from literature review to assess the impact of knowledge management practice on organizational performance that displays a lack of concrete and systematic review of the current state of the art on the influence that knowledge management practice has on organizational performance. And this leads to the establishment of our research question. 3 research questions were developed. The first one is, how do contracts of knowledge management practice and organizational performance develop over time? The second question is, what aspect of organizational performance absorb the impact of knowledge management practice, and what is the path of influence? And the last question is, what are the limitations or the knowledge gaps of this research area? By answering these 3 research questions, we aim to deliver further insights into the relationship between knowledge management practice and firm performance. Methodology. We follow the literature review method outlined by Myring and the bibliometric analysis using R programming language proposed by Nobre and Tavares. Both 2 methods have been recognized for their quality by publication in high-ranked information system journals. We propose 4 steps of our systematic literature review method are literature search, descriptive analysis, bibliography analysis, and findings. Following the above method, we use the bibliometrics library in the R Studio to operate descriptive analysis, factorial analysis, and multi-factor correspondence analysis. And this is our literature collection procedure. Due to the knowledge management practice and firm performance involve emergent concepts, We cover literature published in the last decade from 2010 to 2021. This setting is to observe the evolution of the critical concept adequately. These search strings were developed to search by topic using exactly the search string of knowledge management practice and organizational performance or firm performance. There are 3 layers in the literature search procedure. The search strings remain the same in 3 layers. In the Google Scholar search layer, the search result gave us an initial picture of the existing studies in the review period. We then filter out qualified and relevant articles published in the leading IS journal. Next, we use the same search string to search on Web of Science and Scopus databases. We then cross-check the search results from the academic databases and the Google Scholar to eliminate duplication. Finally, we select 52 scientific articles to conduct bibliometric analysis. Literature findings. This is our descriptive analysis result. It is notable that the numbers of publications and total citations had significantly increased in the period from 2014 to 2019, reaching the peak in 2014 with total citations of 504. This upward trend in research on knowledge management practice and organizational performance could also be seen in the database search layer. It reflects the growing interest in the research area from academia. Regarding publication source, all the articles in this review were selected from high-ranked journals. Significantly, the substantial number of citations reveal that although the research domain of knowledge management and organizational performance is major, the sought impact tends to keep expanding. This result also proves that the articles chosen for this literature review are outstanding and thus could represent a typical research stream in the information system domain. This 3-fields analysis was conducted using R programming algorithm to define the unique terminology and associated references source of the articles in review. We first calculated the broad area of index keywords and compare how the key concepts were connecting. We then selected the most outstanding concept to represent in the form of a 3-fields plot. From this figure, it is evident that the concept of knowledge management practice, and intellectual capital have intertwined in the studies of innovation, organizational performance, and innovation performance. It also shows that the research area of the knowledge management practice relates to a broader domain, which is knowledge management and intellectual capital. Similarly, the concept of performance bonds with innovation performance. This figure represents a strong connection between knowledge management practice, and wide-known reference sources. It supports our research focus and findings. This graph represents clusters of the key concepts. It displays key concepts and their relational networks. The inclusion index was weighted by worst occurrences in the selected studies. We then developed a thematic map that addressed the analysis results from 52 papers. The relatedness between knowledge management and firm performance was distributed into 2 main clusters. Each color represents one cluster connecting its network actors by the same color lines. Analysis results show that knowledge management is a core concept interlinked to 2 main clusters. Notably, based on analysis results, we found that the concept of innovation established a broad network throughout 2 main clusters. This finding supports descriptive analysis results. This is a conceptual structure map created by using the bibliometric library for multi-correspondent analysis and multiple visualization packages in RStudio. In our measurement, we consider all the index keywords as individual variables and calculated the contribution of active variable groups to measure the distances between variables. We put efforts in addressing the most critical variables that represent dimensions. Following the multi-correspondent analysis, we deliver an observation that contains a set of variables that describe the knowledge management practice dimension and another set of variables that describe the organizational performance. This figure shows the distinguished level of correlation between knowledge management practice and organizational performance. The multi-correspondent analysis result indicates that knowledge management practice relevant concepts are closely associated with firm performance, as suggested by prior qualitative and quantitative studies. In addition, the analysis results reveal a tighter correlation of organizational performance in dimension 1 at 32.11%. The second dimension, which represents knowledge management practice, shows a lower correlation rate at 22.2%. In the first dimension, significantly, the variable financial performance reaches the highest value of the dimension, representing the value of the performance dimension. In the second dimension, knowledge sharing, knowledge-based system, and knowledge-based view are the three key variables to observe. And these three variables are positively correlated with variables in the organizational performance cluster in both dimensions. These analysis results are similar to findings claimed by multiple earlier review studies. The intellectual structure analysis is to give insights into the outstanding contributors of the field. The bibliometric analysis results indicate that existing studies on knowledge management practice and organizational performance were developed on the ground of the high-impact authors such as Fornell, Nonaka, Cohen, Colgate, and so on. I believe that anyone who is doing the research on knowledge management domain will be very familiar with this name. So this is the intellectual structure map we want to present. Analysis results on collaboration networks display a dominant collaboration between North America, Europe, Oceania, and Northeast Asia. This result figures out the missing collaboration between other regions such as other European countries, Russia, and Oceania. Object-oriented analysis. In searching for a solution that could have effectively addressed the relationship between knowledge management practice and organizational performance, we developed an object-oriented framework that acts as a categorization method. In this framework, each dimension of knowledge management practice and organizational performance would be viewed as an object. Subsequently, we carry on a comparative analysis regarding the occurrences of objects and their associated arguments. The asterisk represents the occurrence of the object. In this object-oriented framework, we define the reference type arguments under knowledge management practice and organizational performance. This means in our analysis, knowledge management practice might have a cluster with one argument, which represents one typical aspect of organizational performance. At the same time, such argument might have another independent object, which is organizational performance that refers to it. In other words, one argument is related to two objects in the form of variable references. Following this framework, the details of objects in each study and their reference factors will be properly illustrated. The analysis results of the two fields, which are knowledge management practice and organizational performance, would also reveal the gaps of the research domain, which areas are the major research domain and which area lack attention. Following the proposed framework, we conduct a further investigation on selected articles to deliver comprehensive classification from multiple perspectives. The results show three main classes categorized based on research methods that are design science research main class 1, qualitative research main class 2, and quantitative research main class 3. Conclusion. Literature review findings show a major picture of research on knowledge management practice and organizational performance. The assessment results indicate that studies on knowledge management practice often focus on knowledge creation, knowledge sharing, knowledge acquisition, and knowledge application. Notably, knowledge management practice is directly associated with several types of organizational performance, namely finance, economic, operation, innovation, human resource, team, and leadership. Nevertheless, the measurement of firm performance usually refers to financial performance or financial indicator. Current literature shows a lack of studies regarding the impact of management style and knowledge management process on new product development strategy and leadership performance. There is a lack of studies using qualitative research methods such as field study and grounded theory. In addition, there is an absence of research conducted under a critical perspective. In addition, the frequent occurrence of innovation objects across studies might be a result of the high involvement between knowledge management practice and information technology. This finding matches with the prior analysis results of conceptual structure. It reveals that the significant part of influence that knowledge management practice produces to organizational performance is likely through innovation and information technology. Research on knowledge management practice and firm performance therefore should look at the object in the three key fields: knowledge management, organizational performance, and innovation. Contribution. This literature review delivers to academia, firms, industry, and government a better understanding of knowledge management practice and the vital role of innovation in improving organizational performance. Thank you very much for watching.
everyone. It's a pleasure to be here today with all of you. Today, I am honored to present in EAI CCASA 2021. Our topic is predicting humans' balance disorder based on center of gravity using support vector machine. Our team has 6 members. All come from Hanoi University of Science and Technology and Vietnam National University. Our presentation has 5 parts. The first part is about definition of balance disorder and COG device. The next 3 parts are about data collection and data analysis. The final part is results and conclusion. Let's come to the first part. A common condition that usually happens with older people is balance disorder. When a person has balance disorder, they may have the feeling of dizziness, unsteadiness, or a lightheaded status. They feel hard to keep balance or fall down when changing position. According to a statistic, there are nearly 8 million adults in U.S. diagnosed with balance disorder. Drawn out from this survey, about 1/3 of the older population are considered having bad ability to keep balance. This symptom is observed more for patients more than 75 years old. Due to the speed of industrialization, Vietnam has more and more people suffering from balance disorders. There are 4 main systems in the body that work together to ensure a good postural balance: inner ear, vision, muscle and joints, and sensory input. When one of these systems does not work well, the patient might feel uncomfortable and get psychological problems. If balance disorder occurs more frequently than normal, one may suspect the presence of a particular disease such as a cardiovascular problem, or a damage in the nervous system, or a dysfunction of our vestibular system. Diagnosis disease relating to balance disorder is sometimes difficult because of overlapping symptoms and shortage of medical equipment in some healthcare centers. When suspecting a disease relating to balance disorder, one needs to see doctors for better diagnosis and proper treatment to prevent exaggeration of the disease. There are 2 methods for determining balance disorder: qualitative and quantitative. For qualitative method, doctor diagnoses the level of balance disorder mostly based on personal experience through clinical examination and reflects on the patient's condition. Quantitative is method using advanced equipment to assess patients. In Vietnam, doctors usually using qualitative method. They depend mainly on physical examination to assess patients, which sometimes result in inaccuracy. Besides, a quantitative method named center of gravity is proposed and briefly described as the aid of balance disorder diagnosis. For a biomedical engineer, it is important to comprehend doctor's demand, so for a year, my team have been working with a device that can record people's center of gravity and process data to help access balance status. This device is made by our group to record real-time cog signals. It is in a simple design with Arduino microprocessor and 4 load cells, based on postural sway analysis. The device collects data on the mass that the human body produces over 4 sensors and then applies the formula to find the fall of the center of the human body on the plane. The center of gravity is an imaginary point around which the body's weight is evenly distributed. For patients with balance disorder, their COG points oscillate around normal ones due to bad ability to keep balance, so their COG patterns may be different. The device aims at some purposes below: record all mechanical forces applied on 4 sensors and display in real time. Connect with the interface to display the calculation of COG and visualize it in real time with graphs. Store data and export to Excel file for further data analysis. Optimize patients' data management in the hospital. This device is only used for data collection and it aids me in my data analysis. Our first design has been tested in 2 hospitals, universities, and an article has been posted in RICE 2019 conference, The Intelligent Computing in Engineering. While developing the device, we're going to collecting data. Sets of COG data from people with and without balance disorder are collected with COG device. Data collection takes place in 2 hospitals and Hanoi University of Science and Technology. There are totally 78 participants in both young and old group. Based on each patient's medical record and treatment state, each volunteers will be in one of 2 groups. People with and without balance disorder. People in group with balance disorder should have these features. They are diagnosed with a disease that has balance disorder symptom. Typically vestibular disorder, high blood pressure, BPPV. Cerebral circulation insufficiency. They stayed in the hospital for less than 1 week. This ensures they do not undergo so many treatment procedures. They still complain about high frequency of unstable state and dizziness. The other group includes healthy volunteers. They are not diagnosed with any disease relating to balance disorder and rarely feel dizzy and unstable. All patients do not have any leg injury that interferes them standing on the device. They do not use stimulants before measurement. After each measurement, a set of coordinate, x, y, is saved to Excel file. Each set of data for each volunteers contains 300 samples, or 300 pairs of x, y, in the time series. And how to convert raw data into useful information. It lies on data analysis. The data pre-processing has 2 problems. Eliminate meaningless data and convert pairs of x, y, into useful features. Set of data for each person contains 300 samples, or 300 pairs of x, y, in the time series. When changing from leg open to leg closed position, the volunteer's coordinate might have artifacts. So the first 100 samples collected in the first 15 seconds will be eliminated and the rest are kept for processing. All meaningless data, containing value 0 for each force, is removed so that the last 200 pairs of x, y, are kept for processing, and this number is identical for all participants. The mean of x and y are used as the new coordinate of origin around which the person sway to keep balance. According to PhD Thomas E. Prieto, this set of data can be transformed to features which can be more meaningful to doctors. Here are 15 features with 7 main features are mean distance, RMS distance, mean velocity, mean frequency. 95% confidence circle area, 95% confidence ellipse area, and sway area. We created a user interface with C# programming language and SQL database. This allows user to import raw COG data, delete meaningless data, calculate 15 features, save calculation and other information, and view all volunteers and export to Excel files. Here is a list of volunteers corresponds to a set of 15 features. We can see the name with notation about their status, and 15 features related COG points. After convert raw data into more meaningful data, we process it. Data processing also has 2 problems. First is assessing the influences of 15 COG parameters on humans' ability to keep balance. Second is classification people with and without balance disorder with support vector machine. The First purpose is to figure out the influence of such parameters on human balance by examining two independent groups. When considering each feature, it is necessary to compare the mean value of two groups, so a method named independent sample t-test is used. Independent sample t-test is used to check whether the mean values of two groups for each parameter are statistically different from each other. There are several tools for independent sample t-test, of which SPSS is chosen for this research. In fact, many data sets are not nearly separable. The data need to cast the original input data into a new space with higher dimension. Therefore, we used kernel trick converts the objective function into a new form. After this function is solved, support vectors will be found, and labeling can be performed next. 4 kernel functions will be used and only the one with highest accuracy will be selected for deeper analysis. To support binary classification, we created a user interface with C# programming language, SVM library. We divided the data into training and testing dataset. Training dataset includes 50 samples, in which 18 samples are labeled as 1, which means they are in group with balance disorder. And others are labeled as -1, which means they are in group without balance disorder. Testing dataset includes 28 samples, in which 10 samples are labeled as 1 and 18 samples are labeled as -1. The division of training and testing data is based on holdout technique. We selected parameters using SVM library in C#. It allows parameter optimization by grid search tool, in which cross-validation accuracy is obtained for each parameter and the one with highest cross-validation accuracy will be considered the optimal value. In order to evaluate our methodology, we calculate the accuracy, sensitivity, and specificity for each classification. Each classification gives us values of true positive, true negative, false positive, false negative, which help to measure accuracy, sensitivity, and specificity. Sensitivity shows the probability a test can correctly give a positive result for people who have disease. For a test with high sensitivity, it will generate positive result for almost everyone who has the disease and return just few false negative results. To compare the accuracy of classifying training and testing datasets, we use 15 features and 7 features. In 7 features, we eliminate the influence of factors coming from 2 axes OX/OY of 15 features. For SVM involves the use of 7 attributes. When using SVM with 7 attributes, the accuracy of classifying training and testing datasets is obtained and described in table here. This leads to a conclusion that Gaussian function is the most effective function in 4 kernel functions with the highest accuracy. Sigmoid function brings up the lowest accuracy, about 64%, and sensitivity, 0%, so it is not a promising function and there is no need to analyze it more deeply. And the second trial has 15 attributes, which means we have 8 attributes as added. When using SVM with 15 attributes, the accuracy is obtained and described in table here. We get the same result that RBF generates the highest accuracy for both classification of training set and testing set. Here are 2 types of SVM performance of 3 ratios. 15 attribute SVM performance of 3 ratios with Gaussian kernel, and 7 attribute SVM performance of 3 ratios with Gaussian kernel. Conclusion, primary objectives are achieved. First, assessed influence of 15 parameters on humans' postural balance. Second, found out RBF is the most effective function. Third, proved that SVM with 15 attributes has better results than SVM with 7 attributes. And finally, thanks all of you for watching our presentation.
Hi everybody, we include Tung Anh Vu, Công Vinh Phan and Cường Phạm Quốc. Today we want to introduce our paper Internet of Things, Big Data Management and Analytics for Developing Smart City, a survey and future studies. First, we want to talk about our content. The first section is introduction. In this session, we will talk about the progress of IoT Big Data in the real life. The second session, we will talk about the survey of IT Big Data Management and Analytics. These surveys are divided into two branches. The first branch is survey of IoT Big Data Management. The second branch is survey of IoT Big Data Analytics. In the sub-session IoT Big Data Analysis, we still divide into sub-session Analytics and Mining and Net 2.2.2 Deep Learning. In the third session, we make survey of security, privacy, and energy efficiency of IoT Big Data. The fourth session is a future study. In this session, we will talk about some research that we will focus on. The final session is conclusion. And thanks for watching. Next, we want to talk about the first section, introduction. The more progressive social is, the more requirement are. The progress of computing helps us to analyze a large set of data. Nowadays, there are many data analysis tools for big data, such as Plenty, Analytics, Microsoft SD Insight. In the first session, introduction, we talk about the total view of IoT. The first requirement is how to connect some network device for communication, and the next requirement is developing of other fields like smart house, healthcare device, agriculture, the smart city, and intelligent traffic light system are not trivial. The higher priority the road has, the longer duration the green light has. The intelligent traffic light can increase or decrease the duration of green light automatically with a massive data of cameras, 4 cameras in each corner, and RFID attached to emergency vehicle. We need to find a way to analyze it. It's the overview of IoT Big Data. You can watch the graph. The first block is IoT Big Data. This is a survey of paper. We can divide it into 3 branches. The first branch is IoT Big Data Management. The second branch is IoT Big Data Analytics. In this branch, we divide into 2 branches. The first branch is Analytics and Mining. The second branch is Deep Learning. And the last branches of overview of IoT Big Data is Security, Privacy, and Energy Efficiency. Next, we want to make a survey of IoT Big Data Management and Analytics. In survey of IoT Big Data Management, the first paper number 14, propose a cognitive-oriented framework named CoIB framework. The first framework includes 5 layers. The first layer is IoT Big Data Aggregator. It collects all data of IoT sensor network. The second layer has 2 categorized clean data and save it in cluster according to behavior and characteristic. Next layer is edge-based storage that has calling and storing function. The last layer is IoT Big Data Analysis. The paper also instructs deploying the framework and cloud computing in the live. The next paper number 1, propose a HEP framework named Unified Heterogeneous Event Processing Framework for event data. The event data is transferred to the framework via common event adapters. In here, a cache have data formatting and data processing to be run faster. The data categorizing in before layers also has data processing effectively in next layer named event processing space. Finally, the data is transferred to endpoint. Endpoint is the web server and a user. The framework event is suitable for analyzing data upstreaming, but the intelligent traffic light system has no data streaming. The following paper number 7 propose Smart Plus management framework. The framework has 3 layers. The first layer is sensor measuring water level and speed of water flow, and satellite taking some pictures of the water flow, and buoys measuring the factor. The second layer is plus data storage. This layer has some tasks such as processing, analyzing, and reducing. We maybe integrate some tool inside this layer. Some tool like Spark, SpyPark, Microsoft Edge inside. The last layer is presentation layer with plus map, where each color presents a level of plus correspondingly. The other set of plus attributes include velocity of catchment, density of forest per arc, and plus preventing attributes has some current season, drainage system, and soil type. The paper number 4 proposed an IoT Big Data Analytics framework named IBDA framework. The framework is developed on the basic of Python language and Big Data Cloudera platform. First, sensors create data and transfer it to HDFS storage. In this storage, to get its HDFS storage need a learner agent as an agent for get data. Then the authors use Spark as major software for analyzing data as soon as it arrives into HDFS storage. The last layer is Actuators, turn oxygen pump, fire alarm, and light on and off, and Cloudera visualization data. We can refer to sensor stimulation with Python code from the paper in the lab. Next, we want to talk about IoT Big Data Analysis. The paper number 5 introduced IoT SIM as stimulation and analytics software. The IoT SIM has total 5 layers. We also refer to stimulation with IoT SIM from the paper in the lab. Next, paper number 3 explains IoT fundamental and IoT tree mining algorithm. The paper also focused on open source tools to mine data such as Spark, Blink, Storm, and Samza. This paper is a good reference for beginners who need to be used to data mining tool. Next, we survey of deep learning. The paper number 16 proposes a model for deep computing. The model interprets tensor is the 3D data that have ability to be called automatically. The paper also instructs calculating errors when the sample is reconstructed. However, the paper don't explain data mining in more detail and just concerned with the result and problem of data. Paper number 5 also proposes a model to do deep learning on data. The model uses an adaptive distribution that have arrays with probability named P. Maximum likelihood estimation is used for estimating parameters of probabilistic distribution to statistic data. The authors use Q and SNAE2 datasets with MATLAB are 20 and 14 and a high performance letter. The next session we survey of security, privacy, and energy efficiency in IoT big data. The paper number 6 also survey of security and privacy in IoT big data made by Karen Scholing. The author wants to clarify challenges in the future research. Therefore, we will not survey security and privacy in more detail. The following paper number 8 is a request-based, secure, and energy-efficient architecture for handling IoT big data. Some relay nodes are put in the middle or use multi-hop system. They have ability to relay data when it is transferred from source to destination. This how to reduce the distance and save more energy. Besides, the system can turn off passive sensors and turn on them again when they are necessary for action. Next session is filter studies. We should have 3 levels of congestion: speed and distance, as usual, medium, and high. The observer's corner should increase more duration of the red line to decrease the congestion of next corner. In addition, the green line needs to be turned on for emergency vehicle and turned back to before status. Use some software such as PySpark, Parks, and some platforms such as CoinP, IPDA. They have built framework and analyze data to create a congestion map. Based on the congestion level in areas, the computer can automatically calculate and define reliability level of waste in the region. Relay nodes and multi-hop systems can be applied to reduce the distance between source and destination. The passive node is turned off to decrease spending energy. The final session is conclusion, and thanks for watching. To build a smart city, we need to develop intelligent traffic light system. It is a system that can change the duration of the red and the green light automatically. The change depends on the congestion level of the observer's corner, the congestion of the next corner, and reliability level of the way. The receiving data is categorized and save it to HDFS storage using some framework like CoinP, IPDA, and we can use some analytics tools like PySpark, Spark are applied to the system for stimulation. Thanks for watching. First, we want to thank you the conference. It helped us review the paper and publish it. The second thank is the team. My team include Cường Phạm Quốc and Phan Công Vinh. We work together in a long time to finish the paper. Next, I want to thank for listener. They spend their time to listen our presentation. The last thing is techniques for edit our video. Thanks for watching.
Hello everyone, I'm Phúc Quang Trần. I'm a lecturer at Faculty of Informatics, People Poly College 2 on the conference ICCAPL 2021 today. I would like to present the paper, the example learning for mining opinion on full review, written by Phúc Quang Trần, Hải Thanh Nguyễn, Hạnh Mỹ Thị Lê, and Hiệp Xuân Quỳnh. I will present the paper as follows: introduction, opinion modeling, opinion recovery, opinion example learning model for mining, opinion on full review, evaluation, opinion summarization, experience research, and conclusion. First of all, I would like to talk about introduction. In recent years, the development of machine learning technique as an illusion on opinion mining and sentiment classification, positive, negative, or neutral. The program of the power approach in machine learning techniques the combination of independent lab to form a brighter light lab. The combination of quick learning to form joint learning. The program is an example learning for mining opinion on full review. In this paper, we approach a new form to ensemble learning for mining opinion on full review. And this work is upon opinion mining recovery test one full review to canvas the review in important features, which are them used for classification using an ensemble learning algorithm, such as random classification forest into sentiment operation is positive, negative, and neutral. Experiment on full review dataset. Next, about model opinion modeling. The first opinion is defined as readable G as S T, where G is the sentiment tariff, S is the sentiment of the opinion about the tariff C. S is the opinion order T is the time when the opinion is expressed. The second about simplify definition. An opinion is an multiple EAI has C T VE the terrorist entity A the terrorist aspects of entity E. One with the opinion A has been given. S is the sentiment of opinion on aspects A of entity E. S is opinion holder. T is opinion plotting time. S can be positive, negative, or neutral. Next, about opinion recovery. We were given an opinion document D and then recover on opinion multiple EAI has T in D. Opinion remaining purpose the following a main test. Test 1. Entity injection and resolution. Next, Test 2. Aspect injection and resolution. Next, Test 3. Opinion holder injection and resolution. Next, Test 4. Time expression and standardization. Next, Test 5. Aspect sentiment classification or regression. Next, Test 6. Opinion multiple regression. Next, Test 7. Opinion reason injection and resolution. And final, Test 8. Opinion verify injection and resolution. Next, I would like focus to approach the learning model, the example learning model for mining opinion on full review. Tip E illustrate an opinion example learning from opinion example learning model is opinion, sentiment, emotion data. Next is opinion modeling. Next is recover on opinion multiple then convert opinion multiple to multiple matches. As input to the opinion example learning algorithm. Then for opinion summarization and Finally, sentiment operation is positive, negative, or neutral. About a principal matrix, we were given an opinion shift principle EAI, a matrix, and find opinion principle is shown as flow. This is a matrix that have 2 n rows and 5 columns. Each line is an opinion principle. Each column is one of each element in the opinion principle. About decision tree. Decision tree is based on the binary recursive partition. The tree partition the predictor by using sequence of binary partition of or cron slip on division variable. The would not of G comprise the anti-predictor space. The knot that is not flip a terminal knot, and from the finally partition of the predictor space H no terminal knot slip into two descendant knot, one on the left and one on the right, according to value of on of the reader value variable. About a random forest. Random forest is an sample of decision tree. Each is depending on a set of random variables. In this way, we implement random classification for it, which the input is also on flow. For a p-dimensional random vector S, where S suffix I belong to a collection that include intensity, effect, sentiment, order, and time. Represent the real value input or predictor variable, Y is a random variable representing the real value report. And the run is to find a prediction function f(x) for prediction y. About the evaluation, the performance is measured using the confusion matrix as follows in table 1, where TB is count opinion multiple correctly classify positive sentiment. TN count opinion multiple correctly classify negative sentiment. FP equal opinion multiple incorrectly classify positive sentiment. FN equal opinion multiple incorrectly classify negative sentiment. Beyond the confusion, evaluate the sentiment classifier through the measure and accuracy, precision, reckon, recall, and X measure. Next, we implement opinion summarization. An opinion summary important center on entity and apex and sentiment about them, and econ and best by opinion summary. The fourth on the general member of opinion holder who are positive about E. Member of opinion holder who are negative about it. The second is effects on 1. Member of opinion holder who are positive about it. Member of opinion holder who are negative about it. Final is effects and member of opinion holder who are positive about effects and it. Member of opinion holder who are negative about effects and of it. When general represent the entity E itself and E the total number of aspects of A. Next, I will present experiment result. In experiment about data yield, We use a full review dataset to run the model on two different scenarios. The dataset comes from Amazon File Full Review. This dataset is with more than 500,000 reviews. The reviewer express their opinion and the final point, meaning very negative to very positive. Next, I permanent resources. The first one, we reprocessing and remove not value in the dataset. The second process balance distribution of dataset. The next is permanent the opinion recovery test in session 3. The result obtained from the search-in table 4. It is used as input for opinion ensemble learning. About the tool use, I approach a technique implement using a language package tree and random forest were elements for this experiment. In addition, we also approach to element package NLE to perform test reprocessing data. The experiment path is built on two scenarios and flow. Scenario 1 is for product aspect. The measure of random forest classification on the full review dataset with important attribute aspect in table 5. The measure of random forest classification on the full review dataset with important attribute aspect in table 5. General is for product order or time review. The result of random forest classification on the full review dataset with two important attribute order and time review. The table 6. Finally, I would like to talk about a conclusion. This work has built an ensemble learning model for making opinion on full review. This model is a set of decision tree. Each tree is built on a subset of random variables that are attributes important in full review. Our experiment result identify sentiment organization in full review as positive, negative, or neutral. That on every presentation today. Thank you very much for your attention.
Hit the button to listen support system presented by
paper, we introduce a method for computing with work to find hidden pattern as well as decision support system based on algebra using logistic quality map. Our model consists of a set of vertices in edges whose values are logistic variable contained by logistic lattice. The algorithm for the system study will convert to hidden pattern. Our talk will be organized the following outline. The first one, the first section, we will present some introduction. The second one, we will present logistic fuzzy cognitive map. The third one, we will present computational fuzzy decision support system, and the last one, we will present subdivision and visual. Introduction. In philosophy, the 20th century is said to be the century of language. Even in machine translation start in the 1950s. After generally now, the scientific adventure to computing with language dominated in 1965 when U.S. Air Force declared the machine translation was successful. Research in computing with language continued to in the setting of artificial intelligence. However, the computing was not intelligent in any sense. It's just a tool to rely on intelligent system. A breakthrough was made in 1990 by the idea of fuzzy set or coding work. As the point out, human cognition is nothing more than coding network. In human cognition, we see the world through many intelligent computer work model such as fuzzy neural net, machine learning, machine classifying, and so on have been studied. Hex of hex algebra. Definition: a linguistic cognitive map is a four tuple. A linguistic cognitive map is equal the set of an concept forming the node of a graph, and the second member. The connection matrix E. The third member in the map from concept CI to CIT. And the last member, initial vector recurring transformation function F, is defined. Example 1. Field 1 show the ensemble linguistic cognitive map. Let X algebra is equal a 3 tuple X, C plus, and H. In X algebra with the order L mean the less M is corresponding value, true and true, less true and very true. And now we move to the third section, computational fuzzy decision support system. Hidden pattern in combined and adaptive knowledge network. That's what introduced by Costco have been applied to both the fuzzy logic and neural net as a foundation for development in artificial intelligence application from hidden pattern in pattern classification as well as pattern recognition were presented in some literature in references in which pattern were studied numerical value. These people research on a special hidden pattern that called LHP, which use linguistic variable for three computational phrases: modeling, reasoning, imperative, and verifying. Decision support system in the fuzzy KB. KB means knowledge base, which infer from LHP, the spatial state in space C, when system reach stable state. With algorithm for computing processes, with notation SIG is a member of connection matrix of FCM. It stands of directed H CICG as in algorithm for now the process's computation to find decision support system and LHP that are implemented in some simple steps. The first step, initial system for the first days in the state space. Use a linguistic variable. The second step, recursive computation until system reach final state. The third step, the final state, the final stable state, and the last state, the final early linguistic decision support system derived from LHP. For implementing processes, the following is an example to illustrate the progress of the algorithm 1 about as n equal to 5 step by step. The first step System C consists of 5 states: MCM0, MCM1, MCM2, MCM3, MCM4. Initial state is MCM0, and final state is MCM4. Accelerated variable value present what is present between MCM. System reaches stable state MCM4 after looping 4 times. And finally, we derive DSS, mean decision support system, from MCM4 like that. Now we move to the last session, conclusion and future work. We have introduced a method to computational linguistics for the decision support system, as well as making decision support system. Our next study is as follows. We will consider a complete algorithm to construct decision support system on linguistic domain, applying logic method for verifying soundness and completeness for the algorithm. Thank you for your listening.
Hello and welcome to my talk, Situational Cooperation of Cyber-Physical Agents for Resilient Smart Cities. I'm very happy that I have the opportunity to talk here, and I hope we will learn something together here. Before I start with my presentation, I would like to answer a question that certainly many of you will have. It is the question, where is Kassel? Kassel is a medium-sized, for German conditions, medium-sized city in the center of Germany with about 200,000 people living there. The main focus of business is administrations, logistics, manufacturing, and also some IT companies. Kassel, as it is located in the center, has very, very good connections in terms of motor highways, railways. Major airports are not far away. So that's why Kassel is also a very important logistics place in Germany, and also for meetings. It's very popular. Kassel has a university, and this university is a rather young university. I will talk about it on the next slide. But also Kassel is very well known for its artwork, the museums, and in particular for an exhibition of contemporary art which is called Documenta. It takes place every 5 years, and it's called the most important exhibition of contemporary art in the world. Next year there will be another Documenta, and if you have a chance to go there, it's really worthwhile. Kassel has a lot of tourist attractions, such as a famous, nice castle in a very nice park, and this has been declared a UNESCO World Heritage Site. The University of Kassel is rather young. It was founded in 1971, but it was built on existing institutions such as a School of Art and Design and a polytechnical school which have existed for a long time in Kassel, and other institutions. So it is built on a tradition, but it wasn't called university before. The University of Kassel is very well known for its interdisciplinarity. It has a very interdisciplinary research profile which is characterized by 4 keywords: nature, technology, culture, and society. We have about 25,000 students coming back in this winter semester again to the university after 3 semesters of online teaching. And since 2001 we have a computer science faculty, because the local industry, they came to the university administration and said, you must have computer science in your curriculum because we need these people for our business, and if you don't have a computer science department, we will no longer donate money to the university. So the university came to the conclusion, yes, it's time to create a computer science faculty. Now, let's come to the subject of my presentation. There are 3 key areas, 3 keywords in the title of this presentation. It's cooperation, situational or adaptive cooperation of cyber-physical agents in resilient smart cities. And I'd like to talk about these 3 areas in the following, starting from the last one, resilience of smart cities. Obviously, smart cities are digital cities. They are built on a complex infrastructure made out of communication and information technology, and this ICT is used in all kinds of other services and infrastructures. So the ICT infrastructure is really a critical infrastructure for the digital city. There's a kind of definition for the term digital city. It's a complex networked cyber-physical system that is formed by the extension of the existing functions by means of ICT, information and communication technology, which leads to a variety of different services and digitized processes within these cities. But as ICT plays a key role in such future cities, future digital cities, we have to think about the vulnerability of these cities. What happens if a catastrophe, if some emergency event happens which destroys some of the critical infrastructure of these cities? What can we do to prepare the digital city for such events, for such crisis events? That's the question we asked ourselves, and that this is a real important and pressing question we can see looking at disasters, at emergency situations such as the recent flood disaster in Germany in summer this year, where in a little valley a small river was rising due to heavy rains in the area, and this river grew so big that it destroyed many houses, roads, bridges. It's a real disaster what happened in this R Valley. More than 220 people were called, and enormous economical damage, and they are still fighting to come back to a kind of emergency mode of operation. Many people are really despaired in this area. And we all know about what happened in Fukushima in the year 2011, a big earthquake and a following tsunami which destroyed the nuclear power plant, and more than 15,000 people were killed, and so on. And the infrastructure was destroyed. Communication was partially destroyed. People could not communicate among these rescue forces. The robots didn't work actually at that time as planned because of the radioactivity and so on. So clearly the functioning of digital cities is so far not well understood in case of such catastrophes. And we created a research cluster of research projects which is called Emergent City, where 3 German universities are involved, and the major goal is to make the digital city more resilient against these extreme events and crises. So Emergent City tries to address certain phases of emergency response. If let me get the laser pointer. If an incident happens, if such a catastrophic event happens, then certainly we need, in the first place, we need immediate reaction to save people's life and to prepare for the next step, which is response activities, where some coordinated activities are executed in order to cope with the immediate problems that arise through such an incident. Then we have a phase after this immediate response phase. We have to recover the whole digital city from this incident, and certainly we also need to think about prevention, hardening, preparedness for such catastrophic events. And early warning would also be a concern which we don't work on that much. That's a different responsibility for different organizations. But our research tries to react and find answers to the research questions within this circle activities. So the Emergent City Research project is divided into 4 research areas: cyber physical systems. I'm not going through all of these project titles. Communications, which basically tries to re-establish communication facilities after such an incident. Information services, establishing higher level information services immediately after communications are re-established, are available. And we also have an area where researchers address the societal aspects, urban planning aspects, in order to prepare cities for such events, and also to discuss, for example, legal concerns, legal constraints in terms of privacy of data, security, and so on. My group, we are working on cyber physical systems and a project which is called Coordination of Heterogeneous Cyber Physical Agents. So let's talk about cyber physical agents. Cyber physical agents is a term that would cover all kinds of components that you find in a digital city that collaborate and communicate in this digital environment. Clearly, there's a huge variety of devices and actors in such a digital city, and in particular, in case of an emergency situation, there will be additional robots, emergency rescue forces, all kinds of vehicles, UAVs in the air, drones, and so on. And all of these should collaborate, should be able to achieve a common goal in order to mitigate the consequences of this crisis. For these cyber physical agents, we certainly must assume certain properties such as heterogeneity, autonomy. They act and decide autonomously. They should be cooperative in order to be able to participate in this decentralized system. And as I just indicated, we cannot assume that there is a single central control management station which controls all of these agents. So we need some kind of self-organization, self-managing system here. In other words, these cyber physical systems depend very much on the 3 facilities: communication, computation, and coordination. And the big question is, how can we make sure that all of this works if the infrastructures are partially destroyed, completely destroyed by an emergency situation, by some catastrophe. So there are a whole range of challenges we have to address if we want to achieve this teamwork of cyber physical agents, which I call collective cyber physical agents here. So among these challenges are heterogeneity, I already mentioned, self-organization, no central control, no central architecture, adaptivity. They must be able to adapt to dynamically changing situations. Many of these cyber physical agents will be mobile agents, and the team composition will certainly be changing over time. Some of these agents, for example robots, may fail. They may get out of reach of the communication network. So dynamic changes are inherent in such collective cyber-physical agents for the resilient digital city. Moreover, we need to think about how do we achieve the teamwork? How do we create plans for the team? How do we write software, implement software for teams of robots? Furthermore, how do we realize the collective decision making? How do we design the shared knowledge base? They need some kind of shared knowledge. How do we model the knowledge, and how do we implement this knowledge base? Scalability is always an issue. And also socio-technical concerns are quite important in terms of ethical constraints, legal constraints for these technical systems that have to match the requirements of the societal environment. And in the following, I would like to concentrate on three of these aspects: teamwork, collective decision making, and related to this collective decision making is the design of a shared knowledge base. So teamwork. How do we achieve teamwork? That's the third part of my talk. The title says situational cooperation. Basically, it means how do we achieve this adaptive teamwork. Teamwork is well known to us. We all work in teams, and I'm sure that we all acknowledge the importance of teamwork, not only between cyber-physical agents, but also between humans. And I have found four nice quotes of famous people talking about teamwork. Michael Jordan, the famous basketball player, he said that talent wins games, but teamwork and intelligence win championships. Steve Jobs, who was known to be not the greatest team worker at all times, he said that great things in business are never done by a person, by one person. They are done by a team of people. And Henry Ford also emphasized the importance of teams. And I like in particular the last statement here, which is very short and nice. None of us is as smart as all of us. So we need to collaborate in order to solve difficult problems. Teamwork is not a new topic in computer science. Since the beginning of AI, and since people talked about intelligent agents, they thought about communicating agents. How do agents talk to each other? How can they collaborate? And so in the 1980s, the multi-agent systems research was quite popular. There was a lot of research on teamwork models for multi-agent systems and some platforms for multi-agent systems. This kind of disappeared a little during the next decade, but since 2010 roughly, when robots became very popular for all kinds of services, for all kinds of smart home, industrial applications, digital city applications, robots everywhere, and this created also the need for more research for multi-robot systems. And certainly this will continue, just like distributed computing arose from PCs and all kinds of different computing equipment. We will have distributed robot systems, multi-robot systems working in the future on joint tasks. Even Bill Gates, quite early, he said that there will be a robot in our environment, in every home. And like technologies such as distributed computing developed, we will see the development of groups of robots that can work in concert. They will be networked, they will collaborate, and these groups of robots will be state of the art for in many applications. We already know that there are many application areas where groups of robots, multi-robot systems can be applied, such as service robots in the smart home, search and rescue scenarios. I already talked about it, and I will talk about it a little more. Then Industry 4.0, where we have a lot of robots already, maybe not autonomous robots, but this will come. And clearly, autonomous driving is also an application area for autonomous devices, autonomous vehicles that have to collaborate in order to provide a safe journey on our streets, in order to cross intersections, in order to react to lane merging on the Autobahn or other kind of situations. So clearly a team of robots, or in general a team, can be more than the sum of its individual parts. The functionality can be bigger if you have different robots with specialized functions and they collaborate and they can provide their special functions to other robots. They can share the load. They can try to compensate breakdowns of certain robots in terms of self-healing for the team, and so on. There are many advantages, but clearly it's not so easy to develop such teamwork, such self-organizing teams, collaborating teams of cyber-physical agents. So how do we program the behavior of the whole team? How do we, quite importantly, how do we verify the safety and correctness of such dynamically adaptive systems, cyber-physical systems? How do we debug a system? How do we test a system that can change all the time, can change according to the changing environment? So these are questions that we have tried to address, and we came up with a solution which is called ALISA. And let's talk about ALISA. So our approach is based on the question, how do we achieve effective teamwork? And we have chosen model-driven engineering as our basic approach. So we model first using a certain modeling language. We model the team behavior, and from these models we generate the code, most of the code for the cyber-physical agents. So we have developed a comprehensive software framework for team coordination, which provides modeling facilities, design tools, verification tools, and code generation for teamwork. First, we developed this for robot soccer. We participated with our robot team, soccer team, in the RoboCup championships, but later we applied our framework, and we have shown that our software framework also is suitable, appropriate for quite different applications domains, such as discovery missions for robots, autonomous driving, and also emergency rescue scenarios. So ALISA, the acronym stands for A Language for Interactive Cooperative Agents, has two main parts. It is a modeling language and an execution environment, an execution engine. The modeling is based on state machines, finite state machines. So we have, or this designer builds a model of the teamwork with states and transitions and annotations to these states. This model defines the roles, properties, conditions, tasks for these robots, the behaviors for these robots, and the execution of this state machine is based on the state of the robots and their capabilities and the state of the environment. So robots sense their environment using their sensor equipment. They know their own plan, their own goal. They know their own status, and they make decisions based on their own data and the data that they receive via communications from their team members. All of this is stored in a shared world model, and this shared world model is stored on all of these cyber-physical agents of the team members, whereby we accept that this shared world model may be inconsistent on these different robots. Each robot can decide by itself what should be its next step. Clearly, it tries to communicate and align its decisions with the team members, but if it's completely isolated, if communications breaks down, it still has a way to operate based on the stored plan which it received from the beginning. This modeling activity is supported by a graphical editor, the so-called plan designer, and in a PhD thesis, in a recent PhD thesis, we have shown how we can in principle verify ELISA plans using a model checking tool called UPAL. And in an earlier PhD thesis, a student worked on the model semantics. He defined the model semantics formally and showed certain properties of these models. Here's a simple example for an ELISA plan. It's about autonomous driving. When the system starts up, coming from the default starting state, in this case it will enter a state called stop, and in this stop state it could proceed to different states, like a check-up state performing a stop behavior, going back to the stop state, or proceeding to a parking state. Whatever happens in this parking state is described in this parking type behavior. But most likely from the check-up state, the vehicle will enter the drive route state, which is specified in a separate state machine called drive route. If the vehicle is an emergency car, that is, if the vehicle has certain special capabilities which qualifies it as an emergency car, an emergency vehicle, it can enter the emergency car situation state, performing the emergency plan, the emergency behavior, going back to this driving state, and so on and so on. So these behaviors which are circled in red here, they have to be specified separately. And for example, the drive route behavior is shown on this slide. Very simple example. From the drive state, it can enter a crossing, a road crossing, where they have to coordinate with other vehicles trying to pass through this crossing. This behavior will be specified separately. Or here in this example, the street may narrow. For example, a 3-lane freeway may narrow to 2 lanes, and the vehicles must be able to cope with such a situation, and therefore we have this align state, and so on and so on. I will skip this here. As I said, Alisa is not only a modeling language, it's also an execution environment. Execution environment means that from the specified plan model, we generate code, not 100% of the required code, but a large percentage, a large fraction of the code is automatically generated. Certain low-level functions like motor control or specific sensor access protocols, they have to be implemented by the designer manually. The Alisa engine executes on all involved cyber-physical agents, and they receive this joint Alisa plan finite state machine and will execute within this finite state machine according to what I said, according to their perception of the environment. Every agent decides autonomously based on its own perception and the communication with the team members. They have the notion of a shared knowledge base which is stored in all of these agents. If there are any conflicts because of inconsistent data or inconsistent sensor perception of the environment, for example, in robot soccer, one robot would see the ball in the opponent's field, while another robot in the same team would see the ball in the spectators, because somebody in the audience has a t-shirt which looks very much like such a ball. So I just trying to say that there can be conflicts, there can be diverging views of the world, and these will be solved by particular protocols, and all of this is part of this execution environment of Alisa. Alisa provides the following advantages. It's very intuitive to model the teamwork. Even students could easily get into the Alisa world of modeling quite quickly. Alisa has been shown to be appropriate for very dynamic execution domains, for quite different application domains. It's rather robust against failures, diverging sensor data, distorted communications, and so on. The decision making is decentralized. There's no central control except for conflict resolution, which will be managed by one team member. Alisa has a very modular software architecture. It's quite easy to integrate other protocols, other functionality, other knowledge base technologies. And it has been tested in different applications domain, as I already explained. In the Emergent City project, we focus in particular on the application and the usage of Alisa for these emergency situations, where we have this variety of cyber-physical agents that need to collaborate, that aim at a joint goal and try to achieve a joint task. So we need a knowledge base that is accessible to all of them. Perhaps the knowledge base will not be stored on all tiny devices, sensor devices, or whatever there is in such an environment, in such an Internet of Things environment. But we would be able to use edge computing concepts here in order to delegate certain knowledge base functionality to edge nodes in this architecture, or even to cloud computing nodes, which may be not accessible in such an emergency situation. So edge computing should be the right concept here in order to execute certain reasoning steps on behalf of the simple resource constrained sensors things, cyber physical things. Yeah, this common knowledge base, this shared knowledge base, will store static information about the environment and also dynamic status information, runtime information about the state of the city, about the state of the agents, about the state of the involved components. The knowledge base will also be designed such that it facilitates the information exchange between the different infrastructure domains in the city. We are not talking about only ICT here as a critical infrastructure. In a digital city, the electricity network, the water network, the public transportation network, the logistics, all of them will be critical infrastructures themselves, and we need to know about their status in order to come up with decisions how to help these different domains in case of an emergency situation. So we are aware of the manifold requirements that this knowledge base should provide, and in particular it is used in these critical incidents and their appraisal, the reasoning about these incidents. And hopefully it will help to identify also the root causes of the crisis. In Emergent City, we have decided to build our knowledge base on top of a platform which is called FiWare. The FiWare platform is the result of a large open source initiative defining a universal set of standards for data management, for context data management, for management of data related to the environment of some executing cyber physical system. FiWare defines a joint common interface called NGSI, Next Generation Service Interface, and thus it supports the portability and interoperability of applications that need to access context data, environmental information provided by sensors and other equipment in order to enable the reasoning and the management and the processing of this data by applications. This FiWare platform, this FiWare approach has been defined for various application domains, in particular smart cities. That's why we are using it, but also they have data models for smart industry, Industry 4.0, for smart agricultural applications, smart energy, smart home applications, and so on. So for these application domains, data models are available already. Generic data models which can be extended specifically for certain particular application scenarios, but a large part of the models are already available, and all of them are accessible through this general interface. And in terms of, or for smart cities, already a lot of cities have adopted the FiWare approach to model their data and to build applications based on the FiWare results. FiWare will be available on many different computing platforms, so it's really a big effort, and it makes a lot of sense for us in Emergent City to use FiWare and also to be compatible with other applications, with other digital cities. So let's come to the end of my talk. What's next? Certainly there are a lot of open questions to answer. In addition to the usual problems about scalability, performance of systems, fault tolerance, software management, software evolution, we have a few particular open questions for distributed systems people, such as myself. How do we build self-aware teams that are able to react and reason about unanticipated team adaptations? If at design time we could not foresee all the possible situations that the team may encounter, so what can we do in case of an unanticipated event? And related to this, how can a team dynamically adapt its team plan and the strategy in order to cope with such unanticipated adaptations, to cope with kind of default behaviors? Then we need to work further on the knowledge base based on FIWARE. How do we implement the knowledge base in terms of the distributed architecture? How much replication is involved? How about consistency and consensus for the cyber-physical agents? And all of this must be viewed in terms of the dynamic environment, dynamic changes. And also methodology is quite interesting. Can we come up with design patterns for such applications, for cooperative team-oriented applications? The second area, which is very important here, is the socio-technical concerns. How will humans take part in these autonomous, automatic, self-organized cyber-physical systems? What's the interface between human operators and cyber-physical systems? How do we provide trust in the actions that the team does autonomously? How do we explain to the average user what the team and why the team will do certain activities in a certain situation? So trust is quite important for autonomous, self-organizing teams. Also, clearly there are questions of liability. If something goes wrong, who is responsible for errors or wrongdoings? And we need to think about how do we build in normative requirements such as legal constraints, ethical requirements, cultural requirements maybe into the technical systems, into the software, and many more of these concerns. And all of these socio-technical concerns are the major focus of a scientific center at the University of Kassel, which is called ETEC, Scientific Center for Information Technology Design. And we in the ETEC Research Center, we concentrate on projects and research that address the design of technology with socio-technical requirements in mind. And if you want to learn more about it, please look at the web pages of ETEC. Thank you very much for your attention. If you have any questions, please ask them now, or you may also send me an email. You see the email address here. Feel free to ask any questions that you have. Thank you.
Hello everyone, my name is Thanh Khoa Nguyen. I am working in the Gamma Community College. Today I am very happy to present for all of you our work for applying semantic image by Luvan method into the content by image retrieval. Our design has the 5 parts. The first one is introduction, the second is the backup visual world model, and the third is our CDR architecture, and the fourth is experimental results, and finally is in conclusion. Yes, moving to the image retrieval technique. The image retrieval is an active research topic, so it's a many techniques for this research of the text-based image retrieval. It does not meet the demand for user. So the content-based image retrieval has become one of the most hot topics. And the semantics based on the image retrieval can obtain by the textual annotation or higher sophisticated inference procedure based on the visual content. In recent decades, deep learning methods enable the detection of objects belonging to many classes, greatly outperforming traditional computer vision techniques. So the backup visual in general. The backup visual is one of the most popular CBR model that presents images as a collection of the local feature. The backup visuals comprise 3 main stages. First of all, it is finding the region in the index of an image using key point detector in general. The second stage, computing a summary of the region through the use of the feature vector. It's like key point descriptor. And finally, the building the vocabulary to define the common subspace, the vocabulary for all the images. As you can see in the flow chart, with the star, read the vocabulary, read the vocabulary exists or not. It is yes if we read the group histogram, or no, we compute the vocabulary and we store the vocabulary and moving to read group histogram. And group histogram exists, yes or no. If it's no, we compute the group histogram and store the group histograms. And yes, to get image to compare histogram. And we compare the image histogram with the group histogram and give us the final result. I will talk about the key point detection. The key point detection is the process that uses a feature detector to determine region of an image that has unique content such as corner or something like that. Look for points of the index in the image and thus remain local invariant. And this can detect them even the presence of scaling or rotation. Several key point detectors in literature such as Harris, Lalas, a differential Gaussian on Hansian, Lalas, on Massimo stable extremal region, I'm sure. The key point descriptor involves computing a local descriptor, which is usually done on region center on detected index point. Local descriptor depends on the image processing to transform a local visual neighborhood into a compact vector presentation. Key point descriptors are utilized to determine how to present the neighborhood of pixel near a localized key point. The most popular key point descriptors such as ship or sur or glow or histogram of gradient or gradient hawk. The amount of extracted feature descriptors are quite large, so we need to apply the clustering algorithm to cluster the feature descriptor in order to generate a visual vocabulary. The size of the vocabulary is determined when using the clustering algorithm and depends on the size and type of dataset. Enjoy the clustering algorithm like K-means, KNNs, and SVM, and so on. Now we will move into our CBR architecture. In our research, each node in the graph presents a pixel, and X-ray RFID, we generate the complex network. WIZ equal 1 if DIGC lower than or equal T for all the color channel C, otherwise mean, where T is a threshold. IIC and IGC represent the identity of pixel I and pixel Z respectively for channel C. DICC is a measure of a similarity of pixel I and Z intensity for color channel C among RGB. So now we use the pattern to create the complex network for each pixel. We consider a neighboring pixel for vertical and horizontal direction. And we apply the Luvong method to detect the community generated graph and generated graph. The Luvong method is a hierarchical greedy algorithm designed to optimize the multi weighted graph. It consists of two phases that are repeated iteratively. Initially, the area node is a singleton community. At the next stage, we will adjust feature and review the hot mean feature. Haze view is a 15-dimensional vector feature for each region. It consists of 6 elements from mean and standard deviation, and 9 elements provided by hot feature. As you can see, in the figure, from 0 to 8 with the yellow color we use for hot feature, and 9 to 14 it is the standard deviation. We can judge the vector consists of mean and standard deviation for each channel of color. Each region is represented by 6-dimensional vector. For region R, the color feature vector is R power 6, and mean is formula 2, and standard deviation given formula 3, where CI is the color value channel of the pixel I in image, and is the number of pixels in the set R. And we compute the histogram of oriented gradient based on the grayscale image, and we adjust the gradient magnitude and orientation using the 1D center point, the derivative mass, dx and dy in the horizontal and vertical direction to compute the gradient value. The x formula 4 and the y is in formula 5. We obtain the x and y derivative using the convolution operation, formula 6 and formula 7. The magnitude of the gradient is then formula 8, and the oriented gradient is formula 9, as you can see in the slide. At the backup visuals, based on the result we got in the image segmentation task, we will provide a system for image retrieval based on the extracting local feature using backup visual model from the Semantics region. The system yields a feature introduced for the image segmentation methods and compute the register for those segmented regions, using the well-known K-means algorithm to obtain the visual vocabulary. As you can see in the figure, we can divide into the two states. That means training state and testing state. As you can see, on the dataset we convert the complex network, and after that we use image segmentation and we local exact feature descriptor and clustering local descriptor and vocabulary and build the backup visual histogram. And the image query we convert to the complex network. We use segmentation and local feature descriptor extraction and backup visual histogram, and after that we compare to have result. To more detail, we will use the next slide. In this slide, I will talk in more detail about the training state. For it, we implement repeatedly for all the image in the dataset. For each image in the dataset, we read the image individually and convert image to the complex network or graph, segment the image based on the community detection, local methods, and ARI algorithm. Extract a feature based on the sub-segment and associate the characteristic to feature descriptor. Cluster the sets of the local descriptor using the K-means algorithm to construct the vocabulary of K cluster. And for each feature descriptor in the image, find the nearest visual word from the vocabulary for each feature vector using distance match for instance BF matcher, KNN match, radius match, or plan base match. Compute the backup word. Image descriptor is a normalized histogram of vocabulary words and count rate in the image. Save the backup word descriptor for all the images in the dataset. In the testing state, for each image, the query image is converted to graph and segment image based on the community detection, local methods, and ARI algorithm. Extract a feature based on the sub-segment and associate with the characteristic to feature descriptor. They compute the backup word vector with the method defined above. We compare the histogram of the query image with the group histogram and retrieve the best result. So, the next step we talk about the experimental result. Experimental result. In order to evaluate the robot methods, we selected the Corel dataset with a combo of 10 classes. Every class consists of 100 images on the same topics, namely agriculture, beach, buildings, beach, dinosaurs, elephants, flowers, horses, mountains, and food. There is a total of 1,000 images in the dataset for the experiment. We tested one image to all the images in the dataset, so the total tested case are 1,000 multiplied 1,000 images. The experimental results are shown using the qualitative qualitative and quantitative evaluation. For the quantitative, you can see that with the dinosaurs, the picture showed us it is 100%. And the next ingredient is the flour. As you can see that with the 10 picture, the top 10, the top 5 and the top 10 we had 90%. For the quantitative evaluation, we select the core Corel dataset, which is the composite 10 classes with top 1, top 5, and top 10. As you can see that with the top 1 we had 92.25%, and top 5 is 60%, and top 10 is more than 52 to 53%. And we compare with another method. As you can see that our method with 10 classes, it is 60.15. It's lower than Hunter method, but greater than Corel method with 55%. And 3 Vatavas method is 67.16%. And with 9 class, it is 63.84, and 6 class is 77.20, and 9 class with 80.49%. Although our research is not the best, but we can agree that our methods can give for image retrieval. So we robot the content-based image retrieval system for real image, and the methods have also been implemented to look for the most similar images to a given image. Our CBR system in which the best visual model using the local feature that we has robot and adjusted offer an efficient image retrieval method. Although our CBR system has not been implemented on the lab dataset or in deep or extensive experimental results, it has demonstrated its usefulness. We strongly believe that our research will be more advanced and deeper in several future studies. This is the reference. Thank you very much for your listening.
Hi everybody, my name is Hoa. I come from Triton University, Đà Nẵng, Vietnam. I am the first author. I will present the contribute of my paper. The title of my paper is an effective approach for mining key item high utility item set from incremental database. Outline of my talk consists of introduction, related works, our approach, experiment, and conclusion. First, I introduce the purpose. I introduce definition of problem. Give a transaction database, NodeDB, and utility threshold mean putting mining SUI from DB discover on item set for identity is greater than or equal to mean identity. In the sprint, there are two tables. The first one is utility table. It shows the utility of each item in transaction, and the second one shows a transaction table. It shows item in each item and number of each item in transaction. From two tables, we can compute utility of any item set that appear in transaction database. We study the related work of mining SUI. We can divide into two categories. Number one, a tree structure have dropped memory and author use running strategy to avoid errors candidate. And number two, need structure from promising candidate and estimate the utility of item set without this scaling database. From related work, we find out motivation for our paper. The first is previous studies still consume both time and memory because of processing on item in each transaction. The second is decision maker plan a business more effective with SUIs that contain several items. And the last one is big recommendation system is usually sold from 3 to 6 related item of the current item. We propose an effective method to mining key item SUI. Our contribute are shown in this slide. First, we recommend value of k is in 4, 5, 6, or 7 based on studying recommendation system. And number two, we propose a simple list. It's a core item utility list to store key item set contain in training in transaction database. To my key item SUI in database, we do 2 times the following procedure. Step 1. Perform a vertical segmentation for database to obtain sub-partition based on of K. The number of items in each row of subpartition is K. Step 2. Borrow each subpartition to find all K item set. And from the item utility list and mean utility each outputs K item SUI from the K item set in item utility list. In the picture there are two figures. Figure 1 shows one way to segment database, and next picture shows the second way to partition database. From two pictures, we can find K item set. That's find all item set appear in database. We can see subpartition 1 in the first picture, and is different from subpartition 1 in the second way. Next, I will tell about structure of item utility list. It is used to store K item set appear in database, and output K item SUI. The NAT and it is used to update or add during scaling subpartition of database. Structure of each contain two factors. It is there's item and utility. Each row of each store information of a K item set, and utility of an item set is exactly when adding new transaction from incremental database, our update or add the item utility list. We only use a single item utility list with a small capacity of memory. Therefore decrease memory and time for searching element in the list. To my K item SUI, we use two algorithms. This is algorithm 1, mining K item set from subpartition. This is input. Is include DB, mean identity K, and output set of K item set. We use some variable to show this method. This is detailed procedure for mining K item set. We find key item set that appear in instruction in a transaction from M to N. Then we compute utility of it. If item set X exit in item utility list, we update it, and otherwise we add new X in add new X into add X to item utility list. In algorithm 2, we show process mining key item SUI is called EINC key SUI miner increment key item SUI miner. It is not. It's meaning mining key item SUI from incremental database. This is input of it. We use M1 and variable M1 and M2 so through way of database segmentation. L is item utility list that's obtained from the algorithm 1. Z an item set appear in L. This procedure includes three steps. Step 1, mining key item set according to M1. Similar to my key item set with parameter key according to M2. For X, Z belong to in L rule. If we check the utility of Z, if it is greater than or equal to mean utility, then output Z is a key item SUI. We see that our approach brings some advantage. Number 1, mine on a small part of database to degree memory. Number 2, avoid redirection of candidate item set. Number 3, my SUI without rescaling database when changing mean utility. Number 4, propose simply to degree memory and time for searching. Number 5, it is applied for both ordinary database and incremental one. And the last one, it is simple to understand and perform. Next, we conduct experiment in brainmark dataset from FIMI repository. We use 3 datasets including mushroom, chess, and connect. The connect is biggest dataset with 67,557 transactions and 129 items. Our approach is compared to newest method. They are CSUI miner, EFIM glow, CSUI max. uh, on algorithm were implemented in Java. Experiment run on a computer with Core i3 3.8 GHz Intel processor, 22 GB memory, and Windows 10. We use a path chat and collect to limit the running time. This slide shows the performance of my approach on a chat dataset. Table 2 show Table 2 present influence of training mean utility. The maximum time is 1409 millisecond. And number 3 so influence of insertion ratio with mean utility is equal 100. We can see that the time is 286 millisecond. Table 4 shows the scalability test with mean utility is 100. The maximum time it is 879 millisecond. And memory in table is steady on 1.6 megabyte. We go to the result of collect the biggest dataset. Similar to we can see table 5, table 6, table 7. The maximum of memory is about 26.8 megabyte, and the maximum of time is 2000 is about 25 seconds. In table 6 and table 7, the maximum time is about 5 seconds and 19 seconds. Next, we compare our algorithm is compared to other methods. Figure 3 shows influence of training mean utility on mushroom. Our approach is shown on our approach is purple. Figure 3A and B show our approach sharply decrease both memory and time for computing. Next, we can see the influence of insertion ratio. Figure 4 shows that the time for computing of our method is better than other method. Accept value at 10%, and memory consumption of our method is very small. Is very smaller, much smaller than other study. Next, we go to scalability test. Similar figure 5 shows that our approach is better than other method, especially the memory of our algorithm is sharply dropped. Some conclusion are present from my paper. First, number one, we propose a lower effective algorithm for mining 3-item SUI. It has some advantages, including without pre-rating candidate, without rescaling database when changing my identity. Number 3, mine on a small part of database to drop memory, and the last one is proposing a simply to decrease memory and time for searching. Experiment are conducted on 3 brand-mark density database. Results show that our approach is better than compares algorithm. This is 10 important reference of my paper. Thank you for listening.
Hello conference and everybody. My name is Khoa. Today I would like to present my paper that I recover realistic faces from the sketches. Firstly, I want to say something like our motivation for the research and some real problem relating to the study in the paper. As you know, recovering image or translating image is very important and necessary in art or criminal tracking. For example, when we have a very old picture or a blurred picture and we cannot see clearly its detail, so then we want to recover that old picture to another with higher resolution to easily to see. Or on the other hand, in criminal tracking, by applying computer vision, we can translate an input image to corresponding output. This is called useful when we have an input scan of a criminal through the description of a witness, and then we can reproduce photorealistic in higher resolution of that criminal, and that's for tracking criminal easily by police. And here we mention some useful application with our study. And you can see we can use the knowledge of our study to create security, monitoring, or identification system for airport, and we can apply the study for art, for fashion, entertainment industry, animation in cartoon industry, and so on. Next, we move to the problem introduction. In this session, we will introduce the first idea of converting image. The first idea of converting image or translating image come from the famous author named Philip Isola. Philip Isola is the first author, and he very famous in this field. He suggested a notion of employing deep learning network like CNN to change an input image to a different output image in 2007. You can see some example of him in this ring. You can see many groups, and in each group we can see two pictures. The left picture is the input, and in the input the image very old, very blurred. You can see it in sketch, or it in grayscale, or in other format, but best format. And the right picture we can see it very clearly, very colorful, and very easy to recognize any object in this picture in the right panel, right? And here is the illustration of converting image by Philip Isola. And here is the overall of our model. For our model, input will be a sketch and output will be a realistic photo. The sketch will be transferred to our model. Here may be a CNN network, and it will generate a realistic photo in output side. You can see here, and this is overview of topic goal in our study. And here is the database for our experiment. The database we can see it exists in pair. For each pair we can see a sketch and a photo in each pair. This is sketch and this is photo or route trust photo or route trust image. right? Okay. Did a sketch and did a routed image or real image? So now we move on to the something about general knowledge. In this study, we research generative adversarial network or GANs. We can also call GANs, GAN network model. And here is the general of GAN, general structure of GAN. And here the objective function of GAN. Maybe you know it's a very famous objective function of GAN. This is general knowledge. Now we move to an important point. Session 4. In this session, we mention ROPO methods. For the ROPO methods, in our study, we have mainly three contributions. The first contribution is we improve loss function based on combine of pixel loss and context loss. And the second contribution, we evaluate the quality of translated image based on the matrix structural similarity index. We call name SSIM. We call with name SSIM. And we support face recognition framework. This is also suggested by our study. And the final contribution, we evaluate the quality of translated image by visual observation or by our eyes. Now, we can say in the screen, this is a robot training model of our study. We can say we use GAN network here. This is a generator in GAN. And this is input a sketch. Sketch will be transferred to the generator in GAN network, and the output will be a realistic photo of fat image. You can see here, fat facial image, and fat facial image will be transferred to a discriminator in GAN network to get different with real image in training set. This is a routed image I mentioned last time. And this discriminator will find different points between of them by the loss function. Here a total loss function. This is a combination of pixel loss and context loss to find the coefficient, and then the network will the coefficient to turn and training the model here, the generator. The final purpose of our study is find a way to improve the loss function, and the result we expect a effective generator here. How to build a effective generator here? Because we use this generator for the main purpose in overall our study. With this generator, we can test an input in sketch format, and we generate a realistic photo. This is a main purpose of our study. And we do anyway with loss here to improve the generator here. So now we can see detailing about generator. Generator is really a CNN network. It's a convolution network. We can say this is a encoding file, and here a decoding file. For encoding, we started the size of each layer in encoding, and here a also similarity. For encoding, we use the convolution network with size 4, multiple 4, and style 2. And for decoding network, we use also convolutional network with kernel size 4, multiple 4 with style 1. And the final layer will be a convolutional style 1. Also in the also with the kernel size 4, multiple 4. You can see here. And from input image, it will be transferred to the generator, and we get an output here. Output is a realistic photo or image with colorful and recognizable. And here input, it's very blur, it's very simple in sketch format. Now here is architecture of discriminator. Discriminator here right, and here is detail. Discriminator is use Pascal architecture with 4 convolutional layer and style 2. You can 4 convolutional layer here, and here is the size of each convolutional layer. 256 multiple 256, and divide to we can get 128 multiple 128, and so on. The output is just style 1, because we want to get the result in true or false. That means we just need to know an input image is a fake or real. Fake image or real image. With an input will be transferred to this discriminator. We want to the output true or false. True it means real image, and false it means fake image. This is principle in GAN network. Maybe you know this principle. It play game win-win to illustrate the principle of GAN network. And here is a detail of pixel loss. Pixel loss, you can see the formula here. Pixel loss is used to compare two images. The first image is YI. YI is image reliable generator. You can see here. This is YI. YI is also named fat facial image. And this is SI. SI is round trust image or real image. You can see here in this formula. SI. And a number of image in the training set. For the context loss, the context loss is used for convert a real image to grayscale image, and also it convert fast image. A fast image is generated by the generator in the last step. The context loss will transfer the fast image to grayscale, and then we use KL divergence matrix to compare to output here to find the different of them. So finally we use total loss here. Total loss is combine pixel loss and content loss, a combination of between pixel loss and content loss. And total loss will combine pixel loss and content loss based on two coefficients. The first coefficient is alpha, and the second coefficient is beta, where alpha sum beta equal 1. Here is robot regression model to evaluate translated image. to evaluate the realistic photo generated by generator, we use this framework. The principle of this framework like this, we use sketch in the testing subset sketch, and we pass it over the generator. The generator is changed by the total loss in the last step, and finally we get effective generator, and we use this generator to change again testing subset. For testing subset, we pass a sketch to generator to get a realistic file image, a fat image, and we compare fat image to the real image or rounded image in testing subset by matching via magic structural similarity index measure to find the picture nearly similarity with this picture here, and we can recognize who in the picture by the label here. We call on a picture in testing subset on label. This is a experiment of our study. We experiment on two database. The first database named CUFS, including 188 sketch photo file image. You can see here. This is some example of Q database. This is a database generated by author in Hong Kong University, and with the size 200 multiple 250. And here is another database in our study named Eai database, including 123, and you can see some example here with the size of its image in dimension 162 multiple 192. It's smaller than this database. And we use two magic Eclipse and structural similarity index measure for on our study. For on formula in our study, we just use two metrics. This is evaluation methods. And for the total loss, as I mentioned previously, we combine alpha and beta for pixel loss and context loss. We overlay to 11 configuration. We name configuration like 0, 10. It means alpha equal 0 and beta equal 1. It's a likely way for the configuration 19. You can say 19 is mean alpha 0.1 and beta 0.9, and so here is accuracy statistics of its configuration here. You can say the accuracy statistic, and we find a graphics to visualize the result here. And this is a special session except evaluation the experiment by accuracy here via configuration. We also evaluate the result of converting or translating image in our study by visual observation. It means we use our eye to evaluate the result. You can say for the configuration 01 here, we can reduce the output like here. You can it's very bad for configuration 1010. But in the configuration 2A, the output will be improved. You can see here the picture is clearly and colorful. And for the configuration 7 thus we can see the picture very clearly and very good. The output very good and very clearly. Like also. So we decide to show the configuration 7 thirds. It means 0.7 alpha and beta will be thirds 0.3, and we get the best result with this configuration. You can see here this is best result. So we decide to show this configuration to make a generator for translating image. So in the final session, we started it something like the study had 3 main contributions. You can see here. The training phase, we improve the overall loss function to help training generator network, helping to generate a high quality related image from the scan image. For the testing phase, we roll out a face recognition model to test the quality of translated image based on SSIM matrix to measure different each of them. And we reinforce the assignment of the quality of generated image through direct visual observation, like here, as I mentioned. This is visual observation. And thank you.
Hello, my full name is Trương Thị Thanh Loan. I'm from Vĩnh Long City, Vietnam. I would like to represent the other group that includes Huỳnh Xuân Hiệp and Nguyễn Thanh Hải from College of Information and Communication Technology, Cần Thơ University, Cần Thơ, Vietnam, and Phan Anh Trang from Faculty of Information Technology, Vĩnh Long University of Technology Education, Vĩnh Long, Vietnam. I would like to present the content of the article with the title Region of English Selection on Language. In this study, we propose a method for region of English selection on language and classification with transfer learning. The data were used from the Land Pathology 2020. I divided my presentation into four main parts: introduction, language classification, experiment, and conclusion. First of all, I will talk about introduction. Language is one of the most influential factors in agricultural production. It can affect product quality, quantity, or yield of crops. Diagnosis of language is mainly based on the experience of farmers. This is very time-consuming and arduous. Moreover, due to significant growth numbers and less disease symptoms, the farmer experience less understandable treatment results. Methods have been developed to assist in language identification. The technique commonly used to detect language are ELISA and PCR in relationship to the segmentation and classification of this image with a complicated background using defining a study in relationship to. The average accuracy value for the list classification of 150 text images using VCG 16 is up to 91.5%. The other in relationship field propose an automatic detection framework based on defining inventory for upwardly disease classification. The best classification accuracy of 94%. Identifying the disease correctly when it first appears is an essential step in effective disease management. Inaccurate diagnosis and treatment can lead to excessive or insufficient chemical use, increased production costs, or potentially significant disease arrest. The digital imaging and machine learning have shown tremendous potential to pick up diagnosing language. Automatic classification of language is an important research topic in agriculture. It helps to detect disease at a very early stage. Transfer learning is an appropriate approach to building trunk taxonomy networks using legal data. Using transfer learning to adapt existing neural models for visual categorization tasks in image classification. In this paper, we propose a new approach to classify language based on transfer learning. To help enhance the classification result, we have looked at two segmentation approach. Region of English selection use KNI detection and what is this transformation. We perform transfer learning with deeply trained model to develop a left classifier. Let's now turn to the second part, language classification. Apple rust, apple scab, and mid-below disease may affect the land. Manual infection is legit, vulnerable to mistakes, and requires a lot of human resources and time. The method proposed for land disease classification can achieve high classification accuracy, outperforming humans in many cases. We have used the concept of transfer learning for classification. In image classification, transfer learning is often manifested through the use of rich model. The model of land disease classification using transfer learning consists of three stages: image processing, image segmentation, and classification. You can see Figure 1, the proposed method for land classification. Let's now turn to the first stage, in image processing. Image processing is an important step in image analysis. The aim of image processing is to improve contrast. The dataset contains images of various size and unbalanced distribution of samples among the formats. The input image in the dataset were downscaled to 500 cell multiplied 500 cell pixel resolution from the original size. We have applied many semantic information to the entry data. We use vertical and horizontal listing, random jump, and image with different brightness levels. Image data augmentation techniques are shown in Figure 2. In image segmentation, segmentation is a step in image analysis to subdivide an image into meaningful regions. Image segmentation can help enhance the classification results. We have looked at two segmentation across region of English selection using EAI detection, region of English selection using water system information, region of English selection using EAI detection. Method EAI detection will only work if the target place is in the middle area and the image is a good quality. Results are shown in Figure 3. Region of English selection using water system information. Apply to show a variety of difficult image segmentation columns. Treat the image as a topographic surface. The right level of the pixel in the image corresponds to the local minimum. Each end-to-end area defines a watershed. The purpose is to define hierarchic lines on the topographic surface. Results are shown in Figure 4. In classification, transfer learning is a type of machine learning technique in which the region models are able to leverage their weight to introduce them as the initialization of a new CNN model for a different purpose. We use retrained neural network model in the ImageNet dataset. We transfer learning with such retrained model and fine-tuning them to our algorithm, eliminating the final classifier, combining them with logistic regression. Let's now turn to the third part. I will talk about experiments. Firstly, I will talk about data yield. The result data were used from Land Pathology 2020. The data includes 1,821 images. The distribution of the fallout is shown in Figure 6. The column just shows that the material DC layer must up only a tiny fraction of the entire dataset. You can see Figure 7, sample image from the dataset. Let me quickly explain the graph. Secondly, I will talk about tools for the experiment. Methods have been implemented with Python. Correct and TensorFlow are used to deploy deep learning models. NumPy is used to perform basic math. Using Adam optimized while minimizing pedagogical cross entropy loss. Thirdly, I will talk about model yield. We perform transfer learning with city-chain model. The age of the experiment runs for 40 hours. The dataset is split into training set 85% and validation set 15% of the dataset. I will talk about experiment scenario. For the infection regime model, yield 21,776,548 generable parameters and 34,432 non-generable parameters. The weight values were updated using Adam optimized for each alpha. The accuracy improved weekly from 0.2555 in alpha 1 to 0.9745 and stabilized after 40 alphas. We perform transfer learning with city-chain model and achieve an accuracy of over 90%. Experimental results on considered are present in the table 1. I will talk about discussion. City-chain models are performed with transfer learning technique and achieve an accuracy of over 90%. With infection regime reaching the highest accuracy. The accuracy of the infection regime model is the highest at 0.9745. Infection technique review model obtain the second highest validation accuracy probability of 0.9672. VCC19 ran behind on 5 regime model, achieving a probability validation accuracy 0.9161. Compare the performance of the report method with public results. The accuracy of our training model will better result. Let's now turn to the last part. I will talk about conclusion. Blended identification and classification play an important role in the disease detection, mitigation, and management. This study introduced an approach using transfer learning methods for the classification of Lyme disease. The report model is an example of city-chain model. The system was set on Lyme Pathology 2020 dataset and had an accuracy of over 97%. The method can save compute time and resources and successfully run a new start. In the future, more data at different sites of different disease will be collected and classified. Some references in the article. Thank you for your listening.
Bismillahirrahmanirrahim. Hello, good morning. My name is Dr. Ijazuddin, and as a author of this paper, I'll get the privilege to present it online. The topic of the paper is Memory Constraint Context-Aware Reasoning. So today's agenda is I'll go through the introduction of the topic, then we will go through the problem background, we'll discuss the objectives and methodology, then we will go through an example, and then we will be discussing the conclusion and the future work of this research work. So Wieser's vision of ubiquitous computing to have as a pervasive computing anywhere and different devices communicating with each other. And nowadays, if you look around, the smartphones are an ideal device which can fulfill the vision. A typical smartphone has many sensors in it, GPS sensor, gyroscope, and ambient sensors, accelerometer, etc. So we can use those sensors along with others, and many sensors we can attach via Bluetooth or different wireless technologies, and we can get a lot of information about a user from these all sensors and devices, and that can be used to make a smart system or a system that is aware of its context. Initially, the context awareness was referred to as or it was mainly restricted towards the objects or location of objects and people. But in the recent years, the context has been extended to social and physical aspects of an entity and the activities of a user. Agent-based computing is an emerging computing, and in which different agents collaborate with each other to give some results or to achieve some goal, either as an independent agent or they work in a team. To make sure to have these devices have the reasoning power, there are many techniques, but on a small devices with the memory constrained devices, the rule-based techniques are one of the most favorable systems to be or techniques to be implemented. So, context-aware computing emerged in 1990s with the introduction of a small mobile devices. An active badge location system is one of the earliest example that can be found in the context of the context-aware computing systems, in which the location of an employee can be traced using a badge, and the calls were diverted toward the specific office in which the employee was present at the moment. So, applications of context-aware systems. The ability of a mobile user's applications to discover and react to changes in the environment they are situated in. So if a device can sense its environment and then it can respond to those context, then it can be a part of a context-aware system. Automatic monitoring of controlled environments such as temperature and lighting, and remote operation on classrooms and meetings rooms, etc. Healthcare assistance for elderly people are some of the examples that can adopt the context-aware computing very well. Context-aware multi-agent system, it can be used when we have many agents working together to achieve a single goal. For example, in a smart spaces, there can be a temperature sensor, a light sensor, movement sensor, and a variety of other sensors that can make an environment suitable for a user or a patient or an elderly person who is present at the moment in that room. So all the sensors will work together to achieve the goal of providing a comfortable environment in case of a smart home to an elderly person. Here we have some parts of the multi-agent rule-based system, and we have here a rule base, a working memory, and here we have the rule engine where the match, select, and act part is going to happen. In this paper, our main work is focused on this part, which is the working memory. So resources constraints in context-aware systems. Although we have many advanced systems in context-aware system, but they are not targeting the devices which have resources constraints. For example, small devices deployed in remote areas with very limited memory, limited battery, or communication and computation powers. Rule-based system, which, as I said earlier, that it is favorable for such devices, and it mimic human ability and perform errands typically done by human. Human reasoning can be defined in the form of if then else statements, where the if else contains a minute possible information. Includes medical diagnostic systems, plant disease diagnostic systems, context-aware systems, sensors, networks, etc. So in a rule-based system, typically an expert provides a set of rules that we can write down, or we can code it into the computer. And the expert, all their opinions are taken in the form of if then else statements, which are broken down into rules and facts, and then we process them to mimic the human behavior. Here we have an inference engine. It has 3 parts: resolve conflict, act, and match. Then we have a memory which have rules and facts, and this can be the application interface which receives data from another agent or a sensor. These are some systems which are currently available and which has been compared with our system, and you can have a look at them. So our proposed framework has many benefits, and if it's generic or not, is it context aware, is it for resource boundary devices, is it native, is it rete algorithm based, which is well known for pattern matching, do we have any porting issues, and context reusability. These are some of the parameters that we are very much interested to have them in our system. And on the left side, we have different available frameworks, and their features are summarized here in this table. So the problem statement is how to efficiently make use of working memory to avoid the system going into unstable state, to use currently available memory, not to increase the space. So in this research, our main work is focused on the working memory. While working memory, we divide it logically into 2 sections. One is dynamic memory and one is static memory. In the static memory, we only put those facts which are initial facts and which are vital for the system to start running. Once it's up and running, then it can use the facts available in the dynamic memory. The facts available in the dynamic memory section can be replaced, removed, added, derived as well. So in order to derive some facts, we need to have some space in the dynamic memory section. If there is no space, we have to remove some of the facts that are already available there, and those facts can be the critical facts. So in order to make sure that we have enough space for all the rules to run efficiently, there is a need to make some efficient technique so that the existing space can be efficiently used for the rules to function properly. Objectives are to make the working memory location dynamic and to improve the agent's overall efficiency. So we have stepwise, or you can say that incremental steps that we have taken in order to make the working memory usage more efficiently, and it is the distinct working memory. That is, if we have 20 rules in our rule base and 8 of them have the same output, or the consequence is same, so we can say that if that is already available in the in different rules, so there is no need to add it to the dynamic section of working memory again and again. So we can say that it will be safe if we have a maximum working space or maximum working memory as of 12 or 13 units. So in that case, only the distinct number of consequences will be taken into account. Similarly, then we can take the average of the preference sets, and then we have smart average of the preference sets, which we will discuss in the next slides. So this technique, the distinct working memory, returns all the distinct results and does not show the duplicated values. Duplicated values are shown only once. To apply the DWM technique on a set of 18 different rules, we have the following mathematical terms. We have total number of rules, total consequences of the rules, and we have this total distinct consequences. And then the size of the working memory will be equal to distinct consequences. If we apply DWM technique to gather all the rules that has the same consequences and define the working memory on DWM basis, then we get 9 distinct rules out of a total of 18 rules. These calculations are based on real rules, and the sets can be found in our previous work. Average of the preference sets. The average preference set technique mainly focuses on the preference sets. This is a two-step technique, mathematical notation for the SAPS or ascender, and it has 2 steps. You can have a look. Basically, we are taking the average of the preferences sets, and then we applied, or we just generalized a rule that on average that much of the consequences can be generated. In order to overcome the shortnesses in the APS, as per the APS technique, the size of the working memory for this example will be 9. However, if the value of PHC is less than PA, then the size of the working memory will be 5. This technique will reduce the calculation and checking each and every rule for distinct consequence. In this specific example, it is reduced to 50% instead of checking 18 rules. It checked only 9 rules, which is 50% less. In other cases, this value can be reduced from 20 to 60%, depends on number of rules in the preference sets, having value higher than the average calculated. Then we have the smart average of the preference sets. It also focuses on preference sets. This technique is similar to APS technique with an additional feature that will reduce the calculation factor in SAPS if some conditions become true. Otherwise, it will work just like APS. The SAPS technique initially calculates standard deviation of the available preference sets. If the deviation in the number of rules in each subset is within the threshold limit, the system will request the highest number of memory units required for preference sets among the available preference sets. No more calculation will be required, as it will be sufficient for each upcoming preference sets. However, if the value is above the threshold limit, then the system will go for the plan B. The plan B is same as to follow the APS technique. We have devised a mechanism to efficiently use the working memory, while in the future we want to work further and to make sure not to remove any critical working memory fact. That will be the last step to take, that if in any case or by any chance we must remove any fact that is residing in the working memory. So in order to remove any working memory, we need to be sure that we are removing such a memory which will not be required by the system anymore, and to avoid removal of any critical working memory that can put the system in unstable state. These are some of the references that have been consulted in this research paper. Thank you for watching.
Ladies and gentlemen, my name is Huỳnh Thị Thu Thủy. I come from Ho Chi Minh City University of Technology, Vietnam. Today, I would like to present the paper with the title Semantic-based methods for top-K discourse detection in static and streaming time series under Euclidean distance. My co-workers are Assistant Professor Dr. Dương Tuấn Anh. He comes from Ho Chi Minh City University of Foreign Languages and Information Technology, Vietnam. And Dr. Võ Thị Ngọc Châu. She comes from Ho Chi Minh City University of Technology, Vietnam. And now, here is the outline. Firstly, I will talk about some definitions. Secondly, I introduce 3 supporting techniques. Then I will present our proposed methods and empirical evaluation. And finally, our conclusions and future works. First of all, we go to the definition. The first definition is subsequent. Subsequent is a set of n continuous points extracted from a time series with length m. Normally, n is much smaller than m. Figure 1 illustrates the subsequent SP is extracted from the time series T beginning at the position P. Next, we go to the second definition, that is non-shell match. A subsequent SQ is set at a non-shell match to SP if SP and SQ have no overlapping points. In this figure 2, we can see 2 non-shell matches to SP. They are SQ and SR. These subsequences have the same length and they are not overlapped together. The third definition is the top discord. It is also called the most unusual subsequence. A subsequence C in a time series T is called the first discord if it has the largest distance to its nearest non-shell match. It implies that subsequence C is the most distinct from all the remaining subsequences in a time series T. This figure 3 illustrates the subsequence C is the top discord in an ECG time series. The fourth definition is the top K discord. Given a time series T and the subsequent D of length n beginning at position P, D is called the top K discord if it has the K largest distance to its nearest non-trivial match. The figure 4 illustrates the top 3 discords in ECG time series. Next, we go to some supporting techniques. The first technique is accelerating Euclidean distance calculation. This accelerating is applied in computing the distance between the 2 subsequences. The second one is a leader clustering algorithm. A leader algorithm is using to cluster similar subsequences into the same group and dissimilar ones into different groups. The third supporting technique is EPA leader algorithm. EPA leader is used for detecting the top discord. In this slide, we present the detail of the accelerating Euclidean distance calculation. For the root Euclidean distance, the distance is calculated by this formula. In A leader, we use an early abandon as illustrated in figure 5. We do not need to wait until I is equal to m. As soon as the sum reaches a value that exceeds a given threshold, the Euclidean distance calculation will be stopped. So, instead of I must be from 1 to m, for this early abandon case, I is only from 1 to j, in which j may be much smaller than m. Hence, it helps to accelerate the Euclidean distance calculation between the 2 subsequences. Now, we present the I-leader clustering algorithm. I-leader is an improvement of I-leader proposed by Thủy et al. 2019. Figure 6 illustrates the iLeader algorithm. In iLeader, first of all, the first subsequent is put into a new cluster. Then, consider the next subsequences in turn. Each subsequent is put into a cluster when the distance from this subsequent to that cluster is the smallest among distances from that subsequent to all clusters, and this distance is less than a user threshold. At the same time, the centroid of this cluster is incrementally updated. Otherwise, creating a new cluster and putting this subsequent into this new cluster, and this subsequent becomes the centroid of this cluster. After completing clustering, each cluster is assigned with one of these labels, such as overview, underview, and good. Finally, subsequences in underview clusters are moved to a good cluster that is the closest one to this underview cluster. Then, underview clusters are deleted. iLeader differs from iLeader in the way of calculating Euclidean distance, while all other steps of iLeader are the same as those of iLeader. In this slide, we present the EPI-leader algorithm for detecting anomaly subsequence. First of all, time series T with length M is semantic into subsequences based on extremal points detected by the method proposed by Fink and Gandhi. These subsequences have different lengths, so they are transformed into subsequences with the same length by using a homothetic transformation. Next, these subsequences are put into suitable clusters. Anomaly scores of all subsequences are calculated. And finally, the top discard is the subsequent corresponding to the largest anomaly score. Now, we go to our proposed methods. In this paper, we propose two algorithms for detecting the top K discards. There are top K EPI leader and top K EPI leaders. Top K EPI leader is an extension of EPI leader for detecting top K discards. Top K EPI leader is different from EPI leader only in step 4, that is, top K EPI leader returns the top K discards, which are subsequences with K largest anomaly scores, while EPI leader returns only the top discard, which is the subsequence with the largest anomaly score. Top K EPI leaders for finding the top K discards in streaming time series. Top K EPI leaders uses a moving window to store time series in the streaming context. Top K EPI leaders works with a delay update policy instead of an instant update policy for more efficiency. And this is an illustration of top K EPI leader. After EPI leader calculates anomaly scores of all subsequences, we select K largest anomaly scores. Subsequences corresponding to K largest anomaly scores are top K discards. And this is a circular buffer used in top K EPI leader edge. This circular buffer stores a segment of streaming time series that contains the most recent data points of streaming time series. In addition, this buffer operates its contents in a circular fashion. When handling streaming time series, after the buffer is full, a newly incoming data point will override the oldest data point in the current circular buffer. And Figure 7 illustrates the circular buffer. Now, we present the delay update policy used in CCAPL iLeaderS. In this delay update policy, instead of the arrival of each new data point, we use the arrival of each new major extreme point to trigger the process of CCAPL iLeaderS. That is whenever a new major extreme point is found from newly incoming data points, a process of detecting new TopK discourse in the current buffer is activated. Now we go to the flowchart of TopK EPA leaders for finding TopK discourse in streaming time series. First of all, EPA leader use in scope of circular buffer for detecting the TopK discourse. Then data points come and the process waits until a new extreme point comes. New subsequent is extracted and homothetized. If the oldest subsequent is out of circular buffer, then it is removed from its cluster. Then updates anomaly scores of all subsequences. Next, the top K discourse are corresponding to K largest anomaly scores, continuing with the process of waiting for new points to be transmitted. The process will terminate when no more data points are transmitted. Now we go to the empirical evaluation. To evaluate our proposed methods, we conduct an empirical evaluation with two experiments as follows. The first experiment is evaluating the TopK EPA leader algorithm for detecting TopK discourse in static time series. The second experiment is evaluating the TopK EPA leaders algorithm for detecting TopK discourse in streaming time series. This slide, we present the description of all datasets in experiments. Table 1 shows the source of datasets. Each dataset is belongs to which domain, number data points in each dataset, the period of each dataset, and each dataset is used in which experiment. Next, we want to check the effectiveness of TopK EPA leader. Figure 8 shows the discourse detected by a baseline algorithm named Proof and TopK EPA leader algorithm. For all 5 datasets, discourse detected by TopK EPA leader always match discourse detected by Proof. This confirms the accuracy of TopK EPA leader. Now we want to check the efficiencies of TopK EPA leader. Table 2 shows the running times in seconds of TopK EPA leader and TopK EPA leader. We can see that for all 5 datasets, TopK EPA leader is always faster than TopK EPA leader. And on average, TopK EPA leader is 1.9 times faster than TopK EPA leader. We continue to check the effectiveness of TopK EPA leaders. Figure 9 shows images of top 3 discourse detected by TopK EPA leaders, and Figure 10 shows images of top 3 discourse in ECG dataset annotated by experts. Based on Figure 9 and Figure 10, we can conclude that top 3 discourse detected by TopK EPA leaders are correct. Finally, we want to check the efficiencies of TopK EPA leaders. Table 3 shows the execution times in seconds of TopK EPA leaders after each new subsequent arrives. This experimental result shows that, on average, after each new subsequent arrives, TopK EPA leaders only takes 5.3 million seconds to detect the TopK discourse. Among the above datasets, the electrocardiogram has the fastest recording frequency. Every second, a signal of heartbeat will be transmitted, while on average, every 5.3 milliseconds, Tokay API leaders can detect the Tokay discourse. So we can conclude that Tokay API leaders can meet the requirements of real-time data transmission. And now we go to the conclusions. We propose two effective and efficient methods for detecting Tokay discourse in static and streaming time series. They are Tokay API leader and Tokay API leader edge. In terms of effectiveness, discourse found by our two methods on several benchmark datasets match those annotated by experts. In terms of efficiency, our two methods give fast response to discover Tokay discourse in both static and streaming time series via the experimental results on several time series in various application domains. In the future, we plan to utilize Tokay API leaders in some various real-world applications. Parallelizing the process of Tokay API leader on GPU is also our interest for more efficiency. These are some main references used in this presentation. Thank you for your attention.